Welcome everyone to the second roundtable on practices and standards in forensic authorship analysis, which is this year virtually hosted by the University of Manchester and in collaboration with the International Association of Forensic Linguists. So the first edition of the roundtable was in 2019, and thanks to all of you coming and the speakers, it was a successful event, and David and I wanted to organize the second edition in 2020. But of course, nature had different plans, and we had to postpone our second roundtable to this year. And we moved it to July as opposed to May as in the first one, because we wanted it to coincide with the biennial conference of the association, which unfortunately was also postponed. And unfortunately, we had to move the meeting online, as basically all the other academic events in this year and in the past year. So the goal of this series of events is to advance the field of authorship analysis towards more consistency in methodologies and more standards, and doing so through collaboration across various fields. So we want to create this opportunity to stimulate dialogue and between practitioners from the humanities, computer scientists, forensic speech scientists, and disciplines outside of linguistics, even perhaps in the future. And for example, this year, we are particularly enthusiastic to have as one of our speakers, Dr. Antonissen, who works on individuality in historical linguistic data, which is a field that will probably become more and more important for practitioners in authorship analysis to understand more about linguistic individuality. So we believe that it's through this dialogue that we can collect evidence and then eventually move to solid standards in forensic authorship analysis. So before we begin, and we immediately move to our first speaker, I would like to thank the IFL Association for the support. And it's because of them that this kind of initiatives can happen, and it's thanks to them also that we can advance towards this kind of standardizations in practice in authorship analysis. So the event today, as you all seen the program, we'll start with our first keynote by Dr. Shunichi Shihara from the Australian National University. And that will be followed by questions and a roundtable discussion. So in other words, we will invite panelists and the audience to contribute to the discussion. And to do that, if you are in the audience, you want to ask questions, and if you can, please use the Q&A function as opposed to the chat function, because that allows participants to upvote questions. So if you keep an eye on it, it's possible that someone else has already asked the question you wanted to ask, and you can simply upvote it. And if possible, we'll also, of course, we allow you to ask your question with your own voice, or if it's a short question, we can just read it. And then we will have the lunch break at 12, and then resume for a finish on time at 2:45. The event is being recorded, and most of the talks will be uploaded on YouTube, so you can rewatch them in the end. But let me now introduce the first speaker of today, Dr. Shunichi Shihara from the Australian National University. Now, Dr. Shihara is an associate professor at the Department of Linguistics of the Australian National University, and he is among the most eclectic researchers in the area of comparative analysis of language for identification. And I'm saying that because he's an expert in computational approaches to both voice and text analysis, and also an expert and an advocate for the application of the likelihood ratio for both text and voice comparison. Shunichi has published extensively in this area, covering both methodological and theoretical questions, and he will draw from this expertise for his talk today, which is on the estimation of forensic likelihood ratio for text evidence. And I'll leave the floor to him now.
All right, thank you very much for your introduction, Andrea, and also thanks, David, as well, for organizing this wonderful roundtable during such a difficult time. Can you hear me? That's all right?
Yes.
Good, good. So let me just share the screen, first of all. All right, and then, is everything all right? Can you see my slide?
Yes.
Yeah, yes. Good. Okay, let me just start. All right, so thanks for inviting me to this roundtable and giving me a bit of an opportunity for talking about my research. So as you can see, the title of my presentation is Estimating Forensic Likelihood Ratio for Linguistic Text Evidence with Discrete Models. All right. My presentation is partly actually related to the keynote address given by Professor Stamatatos, and also presentation given by Professor Ebert at the first roundtable meeting in 2019, for those who actually attended. But my talk is actually focuses on or centers around the likelihood ratio framework. All right, and just a few aims of my talk. First one is rather obvious from my the title of my presentation, which is to demonstrate how to estimate likelihood ratios for linguistic text evidence using discrete statistical models. And the second aim is related to the first one, which is to compare the two main methods for estimating likelihood ratios, weight of evidence. And those two are the feature-based and the score-based methods. So the feature-based method is the one I'm going to implement using discrete statistical models. And the other one is score-based method, which is a very popular one for estimating like ratios. But those who are working on authorship analysis, it is distance measures, for example, have been widely used for authorship analysis. So those distance measures can be used as score generating functions in score-based method. So those who are working on authorship analysis, the score-based method is fairly straightforward to understand. But anyway, I'm going to talk about these two methods in details in later. And next one is a kind of hidden aim on my presentation, which is to promote like ratio-based studies for assessing linguistic text evidence. So for this purpose, I'm going to spend a little bit of time explaining how to actually calculate and estimate likelihood ratios, and also talk a bit about how you can assess the system like ratio-based systems. All right, move on to the next slide. All right, the like ratio framework. All right, first of all, mathematical proof has been already given, so that which actually shows the like ratio framework is the only way of assessing the uncertainty inherited in evidential evaluation. Some people actually gave a mathematical proof, and also many forensic scientists, forensic statisticians have been advocating the like ratio framework as the logically, legally correct framework for analyzing forensic evidence in court. And also, this is just another example. There is a paper called Standards for the Formulation of Evaluative Forensic Science Expert Opinion, which was published by the Association of Forensic Science Providers. And this paper actually requires a requires a like ratio is required as the kind of mechanism or tool for reporting the analysis of the French evidence. And also here and there in many places, like the use of the appropriateness of the use of like ratio has been described or endorsed or reported, as I say here and there, kind of in many different places. All right, and also the application of the like ratio framework has been described for various types of French evidence. Those ones you can see are just some of the examples. And also there are standard protocol and assessment tools for validating like ratio systems. So what I want to say here is basically, we are in a really good position to do, authorship analysis studies using like ratio framework, because there are a lot of tools, protocols available. Having said that, although, the presence of like ratio frameworks is really clear in forensic science, but actually studies on the authorship text evidence within the like ratio framework is really sparse. Although there are some studies, so I sort of want to rectify this sort of situation. And as I said, as one of the aims, hidden aim, is to promote the relevant studies. Okay, so what is likelihood ratio? It is simply just as you can see, the ratio of two conditional probabilities. So basically just there are two, usually you work on two different pieces of evidence. X is evidence from the crime scene. You can call it source unknown sample. The other one is Y, evidence from the suspect or source known sample. And HP is the prosecution hypothesis. In the context of authorship analysis, you can call it same author hypothesis. And HD is the defense or different author hypothesis. So idea is, top part is the probability of the evidence given prosecution hypothesis divided by the probability of the same evidence given the alternative defense hypothesis. And the like ratio frameworks is quite often kind of talked about in terms of similarity and typicality. That's a very important concept when you talk about likelihood ratios. But anyway, the likelihood ratio value is greater than 1. The greater it is, the more strongly you can get the support for the prosecution or same author hypothesis. And smaller than 1, the smaller it is, the more support you can get for the alternative defense or different author hypothesis. In the framework, in the like ratio framework, a task of the forensic scientist is to estimate the weight of evidence by means of likelihood ratio. All right, just a quick introduction of like ratio. But I just want to quickly talk about admissibility criteria a bit. It's important. So starting with the famous Dorbert ruling, the admissibility criteria have been set up in various places, as you can see. And the forensic scientists started seriously thinking about how they can comply with the admissibility criteria. So I understand actually, it is widely kind of commonly recognized. There are 3 points to comply with the admissibility criteria. I want to go through each of them one by one. The first one is the transparency and reproducibility. So basically, the transparency and reproducibility of the methodology approach you use for analyzing the forensic evidence, so that someone else actually can test your methodology. That's the idea. And another one is the minimization of potential cognitive bias. So cognitive bias is a very serious issue in forensic science, and the idea is that you have to use the methodology approach, which basically minimizes the potential cognitive bias. And the last one is empirical validation under casework conditions, basically how well the system works under a particular casework you are working on, or something like that. And the importance of these three actually things have been described and talked about, discussed in various documents. And apparently, very last one, empirical validation and the casework coordination is very, very seriously, taken and very, important, considered a very important part of it. And there are a few different guidelines as to how you can actually carry out empirical validation. So Muley, first one, et al., 2017, I think it is written kind of more like a general guideline across different areas of forensic science. And Ramos, 2017, his colleagues. And this is one particularly specifically written for fingerprint, I think, yes. And the last one, which was just recently published, Morrison and his colleagues. And this paper, this guideline is specifically for forensic voice comparison. So that's the thing. So I talked about admissibility criteria, particularly focusing on these three things, because the use of like ratio framework doesn't automatically mean that it is admissible. You have to still satisfy these points. That's the important thing. Okay, so a bit more about the like ratio framework. So usually in many cases in authorship analysis, forensic authorship analysis, the first thing you kind of, typically you have to do is a comparison of two types of documents or text. Okay, one is a source known, the other one is source unknown or source questioned. And the point I want to talk about is basically how you can get to a likelihood ratio. So there are a few different stages you have to go through. The first one is, when you compare two documents, document under comparison, those documents need to be represented. Okay, for that, usually people use stylometric features, using various type of features, or if you want to use the state-of-the-art neural network-based system, perhaps you want to use a neural features or something like that. But important thing is that you need to represent them, okay, using certain features. And then first stage you have to go through is a so-called feature to score stage. So features used to represent the document and the comparison need to be converted to metric, so-called score. So that's the first stage. So feature to score stage. And following stage is a score to like ratio stage. The score at the feature to score stage needs to be converted to a likelihood ratio. The stage is often called calibration stage, but it goes like that. Okay, so two documents compared, and a metric called score is calculated, and then score need to be converted to likelihood ratio. So that's a rough kind of state process pipeline. And at the feature to score stage, there are two main methods you can use. The first one is so-called feature-based method, which I'm going to explain later. And the other one is score-based method, which also I'm going to explain later. All right, that's the rough process. But in the following slides, I'm going to explain each stage one by one. Feature representation stage, feature to score stage, score to like ratio calibration stage. All right, so as I said, when you compare documents, text, they need to be represented, okay, or modeled. So how you can do that, So very typical one, very standard, common, or like standard one is maybe the back of words approach. So using a set of words and calculating the frequency of those words for each text, and you can use those frequencies as feature values, and you can represent each document as a feature, something like that. Very simple one, right? So occurrence of the E or something like that. And also you do the same thing for the other text. All right, so Actually, this is what I used for this presentation, the experiment I'm going to report in this study, because I just wanted to show something, in a simple manner. But once two documents and the comparison are represented using feature vectors, comparisons becomes very, very, very easy, right? Right, so in this presentation, in the experiment I'm going to present, I used a very simple model. So basically, I used the 400 most frequently used words in the entire database, which I used for the experiment. Very simple back of words model. Okay, next stage is the feature to score stage. Okay, feature to score stage. So as I said, when documents are represented model using feature vectors, comparisons becomes very, very easy. Okay, so document A and B are represented, as vectors. Okay, very simple two-dimensional vectors. So you can actually compare them very easy. In authorship analysis, we have been using distance measures traditionally. So you can use Euclidean distance, straight line, the difference or similarity between them, or Manhattan distance, which is the basis for very famous Barlow's delta, or looking at the angle of two vectors, cosine distance or similarity. So idea is you can actually use these distance measures as score generating functions. Okay, the score metrics. That's the thing. So very simple. Okay, next stage is the score to likelihood ratio. How you can get the score, which is something you can get using, distance measures, for example. How you can convert it to a likelihood ratio. Let me just start from the beginning, text representation stage. So you are comparing two texts which are represented with feature vectors. And then you use one of the distance measure to actually measure a score, which tells you how similar or how different they are. Suppose you got the value 10, kind of imaginary kind of example value using a given distance measure. But in order to assess this value of 10, you need additional pieces of information. So those pieces of information, one of them is basically when two documents or texts were written by the same people, what sort of difference or similarity you can observe between those two documents. And the other piece of information is when the two documents were written by different people, what sort of difference or similarity score you can get between them, from them. Okay, you can actually, for the first information, you can use a lot of documents written by the same people. And also for the second information, you can use a lot of documents written by different people. And then you can calculate, distance as scores, and you can plot them to see what sort of differences or similarity you can see. Something like this. SA stands for same author, DA, different author. So this actually distribution tells you, first distribution tells you roughly about maybe 12, okay? 12 is a kind of average distance value or mean distance value, which you can get from two documents when they were written by the same people, roughly about. But DA, 20, maybe that's a kind of a typical value you can get when two documents were written by different people. Okay, with these two distributions, you can assess the meaning of the value 10 here. Okay, so y-axis associated with likelihood. So this actually value tells you if you assume that the two documents were written by the same author, value 10 is the likelihood of this value 10 is likely to occur at this frequency or at this value. But when actually this value is likely to obtain at this likelihood when two documents were written by different people. So actually the ratio between these two are the likelihood ratio. So very straightforward. So this is an example for the score, for a score-based method. More precisely speaking, this type of score-based method is called similarity-only score-based method. But this is fairly straightforward, easy to understand, I hope, for those who are engaged in authorship analysis because you use a lot of distance measures traditionally. However, there are some criticism against the use of distance measures for estimating scores. Typical one, the first one is, there are a few. The statistical assumptions underpinning distance-based measures are often not met where text data is concerned. For example, when you use Manhattan distance, which is a basis for Barlow's delta, the distribution you actually assume for the data is a Laplace distribution. But many other distance measures actually assume normal distribution of the data. But when it comes to text data, actually the assumption doesn't really work all the time. For example, this actually plot tells you the distribution occurrences of the first one, occurrence of the word B. 29 means that this is the 29th most frequently used in the database used for this presentation, which actually, more or less conform to a kind of a normal distribution, but slightly positively skewed. But about, which is a 63rd most frequently occurring word, you can see the distribution start a kind of skewing positively, but there is very positively skewed. So important thing is they don't really not always conform to a normal distribution. That's the important thing. Okay, another criticism against the use of score-based method with the distance measures for estimating like ratio is the reduction of the multivariate structure of the feature to a set of univariate scores result in information loss. At the representation stage, documents are represented using multivariate features, but you actually do a comparison based on univariate score. So multivariate structure to univariate structure simply just naturally leads to some sort of information loss. That is another typical criticism. And next one is the next criticism is the score-based method does not directly incorporate the typicality of the features to estimating scores. Score is simply just a distance measures, so which actually tells you how similar or how different between two documents. So, but like ratio is basically the ratio between similarity and typicality. So when you're estimating scores using distance measures, you are not actually incorporating the typicality information of the features, although it is later converted to a like ratio. So these three are typical criticism against the score-based method, specifically similarity-only score-based method. Okay, let me move on to feature-based method. Okay, so there are some benefits associated with it, feature-based method, based benefit. The full multivariate structure of the evidence is directly used to estimate the like ratios, which actually means more information is preserved, not like a conversion from multivariate features to a single univariate score. And next one, the typicality as well as the similarity of the features are fairly simply incorporated into score estimation, which is good, okay? Because like ratio is, something between the similarity and typicality. But there are some shortcomings. Typical one is that because of the multivariate structure of the evidence, the model becomes very complex, which requires a large amount of data to be properly trained. That's the downside of it. So there is a pros and cons. Okay, feature-based method. So how did I implement it? So I used the Poisson model, Poisson distribution, which is the model, statistical model for discrete data. So which is appropriate for text data, which is essentially just based on count data. So a feature-based method I implemented with Poisson-based models, but I used 3 different Poisson-based models. One is very simple, one level Poisson model, nothing fancy. Second one is one level so-called zero inflated Poisson model. Why did I use zero inflated? Because all of the selected words for the back of words model do not necessarily occur in a given document, which actually result in 0 counts for some words. So 0 count for some words. And the amount of 0 count naturally increases as the word is less frequently used. So to better deal with the issue of large zeros, a zero inflated Poisson model was used. So example is something like this. So 100 there, which is 126 most frequently used word, which is a lot less than B. So as you can see, that there are a lot of 0 counts. So that sort of model should be better modeled using zero inflated Poisson model. Okay, and the last one is the 2-level Poisson gamma model, which was actually proposed by Aitken and Gold in 2013. We just simply implemented. But important point of why did I use this again? So because the text data are actually well known to be over dispersed in their distributions. And the 2-level model, which is also called a mixture model, such as a Poisson gamma model, could be robust alternative for over dispersed data. That's a reason. Okay, so basically I use 3 Poisson-based models. Let me just explain the first one because the latter 2 becomes fairly bit complicated. So, but all of them are Poisson-based models. So if you understand the first one, the following 2 are fairly similar. Okay, this is a so-called probability, Poisson probability mass function for the Poisson distribution, which takes 2 parameters, kappa and lambda. Okay, kappa and lambda. So what is lambda, first of all, which is the model of source known document. That's the model of the source known document. But practically, for example, it is the count of a given word, for example, W1, appearing in the source known document. So how many times you can observe W1 in the source known document, which is a model for one document. And the kappa is a count of the same word appearing in the source question document, the other document. So basically, you can actually compare the occurrence of a particular word in 2 documents. So you can see how similar 2 documents are in terms of particular word. You can get the information in terms of likelihood. Okay, but important, what you can see here is the only similarity. Okay, similarity between or difference between source question document and source known document in terms of a given word, right? But how you can incorporate typicality, which is fairly straightforward, actually. Okay, like ratio. So you can use the formula, something like this. The top bit is basically similarity, as I just explained. The lambda x, okay, you're comparing the 2 documents, x and y. Lambda x, which is the model of the source known document, for example, which is the count of a given word for example, W1 appearing in the source known document. How many times you can observe the word one in the source known document. And Y is the count of the same word appearing in the source question document. So you tell it's calculate in terms of likelihood, you can see how similar the documents Y and X. And the bottom part here is the typicality part. Lambda B is a background model, the average count of the same word appearing in the background data. How often the same word W1 appears in the entire background database, okay, by using the average of it. And Y is the same thing, right? So source question document. So that actually tells you how typical the source question document against the background model in terms of W1. Okay, that's the kind of a way of calculating likelihood ratio using feature-based model method. Right, kind of a quick recap. So feature-based method with Poisson-based models. So basically, scores was calculated for each word. So there are 400 feature words. I calculate score for each word. You can get different scores from different words. Okay, and then those scores, which were separately calculated for different feature words, are fused and calibrated to obtain a single likelihood ratio. That's the process for the feature-based method. But score-based method, which is something I explained earlier. So two documents, source known document, source question document, which were represented using feature vectors. You calculate the difference, you calculate the score between them, okay? So I use the cosine distance, which is a score, okay? You can get one single value, and then the single value is converted to a like ratio using these two distributions. So that's the score-based method. So feature-based and score-based methods. All right, so I just need to check the performance of those two methods for which you need a database. Okay, I use the Amazon product data authorship verification corpus, from which the authors, who wrote actually reviews of certain products, reviewers, who contributed more than 6 reviews, each of which is longer than 700 words, were extracted. So which came down to 2,160 authors altogether. And each of these 2,160 authors contributed more than 6 reviews, 6 or more. And only the first 6 reviews of each selected author were used for the database, for the experiments. And each review is equalized to 700 words. And, as I said, each author, 2,160 authors, each of them has 6 reviews. And the first reviews of each author are grouped as a source known document. That's one. And the second 3 reviews are grouped as source unknown documents. Okay, 2 different groups of documents, or reviews, sorry. Okay, so that is not the end. Actually, there is one more step I actually made. So I actually synthesized documents of different lengths using these reviews. So as I said, the documents of different word lengths were synthesized to find out how the system performed with the different amount of data, word length. For doing that, basically, I used the first review as it is, as a 700 word document. And first 2, I concatenated them as a 1,400 word document. And all of the 3 reviews, again, concatenated as a 2,100 word document. And I did the same thing for the second group, which actually means each author has 2 groups of documents, but each group has 700 word, 1400 word, and 2100 word documents, so that I can kind of check how the actual performance changes, fluctuate depending on the amount of data. Okay, and 2,160 authors. As I said, each of them has 2 groups of documents. And they, 2,160 authors, were divided into 3 mutually exclusive sub-databases of test, background, and development, which actually means each sub-database has 720 authors. Okay, something like that. 2,160 authors divided into 3 small databases, test, background, development, but each author has 2 groups of documents. And from the test database, you can simulate 720 same author comparisons and this many number of different author comparisons. And the background database was used for assessing the typicality for the feature-based method. And development database was used for the score to fit like ratio stage, which is a calibration stage. Okay, tokenization. I didn't do anything fancy at all. No stemming algorithm was applied. Punctuation marks and the special characters were not removed, which actually means they were counted as single word tokens. So nothing fancy. Okay, so let me spend a little bit of time to explain how actually like ratio based system can be assessed. So each experiment, when you actually carry out, what you can get is a series of same author like ratios, and also different author likelihood ratios, as many as you simulated for same author comparisons and different author comparisons, as I explained. And first of all, in order to show the magnitude of the derived likelihood ratios, I use Tippett plot, which I'm going to explain. Tippett plot is a typical tool to actually visualize the magnitude of the derived likelihood ratio. So this is an example Tippett plot in which same author likelihood ratio values and different author likelihood ratio values are plotted separately. But same author likelihood ratio values, there's 720 of them. They were plotted from the lowest one, okay, to the highest one, accumulatively plotted. And the DA, different author likelihood ratios, this is a number of them. They were again plotted from the highest one, this one, to the lowest one, accumulatively. So that you can actually see the magnitude of the likelihood ratio values. For example, about -14, which is a log 10 likelihood ratio value, which is the smallest same author likelihood ratio values. Okay, obviously it is smaller than 0, but this is for same author comparison. So likelihood ratio values, this is a contrary to fact likelihood ratio value. But the other end is the largest same author likelihood ratio value, about 2.5 log 10 value, which is consistent with fact likelihood ratio value. Similarly, okay, this is the largest different author likelihood ratio value, which is about 2.5. Obviously, this is contrary to fact likelihood ratio value, so supporting incorrect hypothesis. And the other end, perhaps it may actually extend a bit more, but maybe -15, roughly about. That is the smallest different author likelihood ratio value. Okay, so you can see the actually magnitude of the likelihood ratio values. So as I said, these ones are contrary to fact likelihood ratio values, which are supporting misleading hypothesis, sorry, incorrect hypothesis. And these are the basically consistent with fact like ratio values. So more away from 0, the stronger they are. So that's the idea. So you can see the magnitude of like ratio value. Okay, and the crossing point is a so-called equal error rate, which tells you about 0.009, so 9% error rate. Okay, that's the thing for discriminating between same author and different author comparisons. Okay, that's the kind of visualization, visual assessment. But the widely used metric is called log likelihood ratio cost. But in usual authorship analysis studies, binary decision-based metrics are quite often used, such as false alarm rate or miss rate or something like that. But important point of likelihood ratios is basically they are continuous values, and the magnitude of them, like ratio values, need to be assessed. So not just higher than 0 or higher than 0, lower than 0, but actually you have to incorporate the meaning of the magnitude as well. But I'm going to explain the meaning of log likelihood ratio later. But the important thing is the lower the better. So closer to 0, the better the performance is. And if CLR value is 1 or greater than 1, which actually means the evidence does not provide any useful information, which means the system actually performs better without the evidence. That's the meaning. Okay, but the point of like ratio values is, CLR is basically assess the magnitude of the likelihood ratios. So in this cost-based function, each derived likelihood ratio gets some sort of cost or penalty. But the amount of penalty you get is really depends. So basic idea is these contrary to fact likelihood ratio values are substantially severely penalized than these consistent with fact like ratio values. But for example, there are 2 values for same author comparisons. They are misleading like ratio values. One is -10, the other one is about -3. They are bad in the sense that they are supporting incorrect hypothesis. So they are equally bad in that sense. But -10 is even worse because they are -10 is more strongly support incorrect hypothesis than -3. -3 is bad, supporting incorrect hypothesis, but magnitude of is different. So which actually means -10 is more severely penalized. That's the point of CLR. But one more time, the lower the better, closer to 0, the better it is. But 1 or greater than 1 in CLR means the evidence is not providing any useful information. And the CLR is a kind of an overall metric assessing the overall performance of a system, which can be decomposed into 2 different losses. One is discrimination loss, CLR mean, which tells you the discriminability of the system. And the other one is so-called calibration loss, which is CLR cow. So CLR is the CLR mean plus CLR cow. So what is calibration loss, which is a very important concept. So if you take a look at these 2, this Tibet plot, same author, like ratios, different author, like ratios, what you can observe perhaps the crossing point is not well aligned with 0, which means actually the like ratio, derived like ratios are not well calibrated, which actually means you can't, when you get the like ratio, for example, -5, you don't know whether actually -5 is really -5 because they are not calibrated. That's a problem. And that is assessed as a calibration loss. But anyway, so CLR is a CLR mean plus CLR cow. All right, let me move on to the experiments I did. So a series of experiments were carried out using different conditions, 3 different conditions. The first condition is the different dimensions of the feature vector. So as I said, I used a simple backward word representation approach in which I used the 400 most frequently occurring words in the database. So different dimensions used for the feature vector to see the performance, how performance changes. So n was changed from 5 to 400. And next one is the defined document length, 700, 1400, 2100 words. Of course, longer the better. And you can get the better performance because you have more information. And next one is the kind of main part of this study, different methods for calculating like ratios. So 4 different methods, but first one is a score-based method with the cosine distance, very simple, standard one. But the latter 3 is the feature-based method. One with 1 level Poisson, another one level 0 inflated Poisson, and the last one with 2 level Poisson gamma model. Okay, so overall result. So overall results, you can see here, cosine, score-based method, Poisson, 0 inflated Poisson, and Poisson gamma. And they are C-error values, C-error mean, C-error curl values are given here for 700, 1400, 2100 words, same for GIS2. So as I said, C-error values, lower the better. For example, for the 700 word documents, actually 0 inflated Poisson perform the best. You can get the smallest like ratio values. Okay, I'm talking about 700 here. Okay, this is the smallest one. But 1400 and 2100 words, Poisson gamma model perform the best. Okay, that's the thing. It's a lot lower, but a lot better than cosine, score-based method. Okay, in these plots, C-error values are plotted as a function of number of features. So one more time, C-error values, y-axis, lower the better. So C-error values are plotted as a function of the number of features from 5 to 400, but separately for cosine, which is a feature-based method, score-based method, and Poisson 0 inflated Poisson gamma, the colored one. They are feature-based method. So lower the better. So what you can see here, rather straightforward. So a feature-based method, how to perform the score-based method. Very substantially. Okay, and perhaps you want to take a look at the Tippett plots as well, just the magnitude of the like ratios. So the top ones, these are score-based method, and bottom ones are best performing feature-based method, 700, 1400, 2100. So what you can see here, for example, between GIS2, okay, so you can see, for example, Poisson gamma model, you can get stronger like ratio values, consistent with fact, stronger like ratio values, okay, for Poisson gamma model in comparison to the score-based cosine model, while keeping the magnitude of the misleading, contrary to fact, like ratio values, fairly small, smaller than these ones, for example, particularly this one. So that's the things. All right, conclusions. Feature-based method, how to perform the score-based method. This is something I kind of expected because theoretically better, better model, inclusion of typicality, and also, yes, there's less information loss. And zero inflated method performed best for a small amount of data out of the feature-based methods. And the Poisson gamma method outperformed for a large amount of data. But anyway, this is just demonstration, another one as to how the like ratio framework can be applied for analyzing linguistic text evidence. All right, that's all of my presentation. Thanks for listening. And yes, I'm very happy to take any questions, comments, please. Thank you.
Right, thank you very much. Okay, so as I said before, so we have this Q&A tab. So if you could ask questions using that tab, that would be fantastic. And if you want to speak, then you can raise your hand and I'll see how that can be arranged. For now, there are no questions, but I have a couple of questions for Shunichi. So if you don't mind, use my...
Not at all, not at all.
Yeah. Okay. I would like to hear a little bit more about the statistical assumptions of distance-based methods, because you mentioned that, and I can see what you mean, but I would like you to say more if possible. See, first of all, if I understood correctly. And
okay.
Yeah.
For example, okay, so when you actually use a distance measure, you assume, distribution and pattern of the data. Many of them assume normal distribution and Barrow's delta Laplace distribution or something like that, kind of equal, symmetrical distribution. That is a kind of typically assumed, I understand. But that is not what you can see from text data. It is natural because the text data, particularly when you use the styometric features, they are based on discrete data, discrete features. So which is natural, they don't really conform to a normal distribution. So that's the kind of starting point. Okay, and there is actually a model for discrete data. Poisson is one of them. Binomial, multinomial, those ones are designed for discrete data. So is that something kind of, am I answering your question?
Yes. Okay. So I understand that. I was just wondering if you can say a bit more about why the data not meeting these assumptions is problematic for the likelihood ratio. Because let's say that you use a score-based method and you know that the attribution is, you know that it works, right? Let's say like delta, we know that delta, provided certain conditions, it works. So if it works, what is the problem for the fact that it doesn't meet the statistical distribution for the likelihood ratio? Or maybe the question doesn't make sense.
I don't know. I mean, it's naturally, it's better theoretically if you want to know if you know the data you have a particular distribution, it's better to use theoretically it's better to use the appropriate model for you, right? So that's simply what I did.
Okay. Yeah. Of course. I was, I guess I was just trying to understand this mismatch, right? So because in theory you would expect that it wouldn't work at all, but we know that, which is it's something that Argamon and Everett discussed as well about delta, right? The fact that it doesn't, theoretically it shouldn't work, but it works.
Yes, that's right. Exactly. Yeah.
So yeah, we don't, I suppose, yeah, we don't know enough about how it works to understand why it is like that.
Yeah, actually I wrote a paper about it, but it's still under review, so.
Oh, yes. Okay, fantastic. Right, David has joined us, and apologies that I should have mentioned that David couldn't be with us at the very beginning of the event because he had other commitments that he had to attend, but he's here now. So I welcome him. Right, so we have a couple of questions in the Q&A. Okay, so I will answer. Let me ask, okay, I'll read the first one. So my question is about text size. In your example, you dealt with texts that are limited in size. What do you expect with larger texts or larger share of features?
What do you expect with larger text? Well, I naturally just expect that the performance will improve further. So that's the kind of main thing I wanted to find out. I mean, from the forensic, really, from the point of view, from the viewpoint of forensically realistic conditions, it might be better to look at the kind of a smaller end than the larger end. Perhaps that's something I really wanted to do. I didn't kind of, didn't pay attention to the large end. So more like interested in when you get the limited amount of data, how performance changes, like a deteriorates. Am I answering the question?
Yeah, well, I apologize if I pronounce your name wrong, but it's Ayuna. Please feel free to clarify that in chat or ask another question if that's satisfactory, if you want to follow up. I suppose the implication would be that if you add more data, then the performance will be better and better and better the more data you add. Would you agree with that, Shunichi, or maybe we shouldn't expect that?
Yeah, I mean, I expect that the performance will improve, but not probably not in a linear manner. Somehow it will kind of, hit the ceiling somewhere, I would say. I don't know. I mean, I'm pay more attention to smaller ends, which is more forensically realistic. So I'm not quite sure about the other end.
Okay, we have another question from Anna. Did you also look at the influence of topic to the likelihood ratio framework? Are your predictions correlated with the topic of Amazon reviews? And what would happen in other domains?
Yeah, that is a really good question. Okay, so the reviews I use for each author, they are all different. So this is actually, I have to say, this is a cross-topic French authorship comparison. So sorry, I didn't really look into the kind of influence of different topics, but probably when you're actually comparing same author documents, basically you're comparing the documents of different topics, which will go against the assumption, right? Because when you are written by the same author, you naturally think they are written kind of similarly, but different topics influenced in the way that they are more different. But when it comes to doing different author comparisons, perhaps when you compare to documents, which are in many cases, they are documents of different topics, which might contribute to emphasizing the difference. That is why perhaps I got stronger, very large like ratio values for different author like ratios. Maybe that's a possible consequence.
Okay, thank you very much. Right, so Ayuna is following up. Yes, I think that the larger the better. My concern is about the fact all measures depend on text dimensions. Moreover, the number of features is part of the problem in calibration tasks.
Yes, that's right. That is, yeah, now understood. Okay, basically the more features you use, theoretically you requires more data, right, to model, train the model appropriately. Yes, probably there is a kind of trade-off. So when you actually use a small amount of features, which is n, perhaps you don't need as much data as you need for large dimension of, larger n. Yes, there must be a bit of a trade-off. Yes, that's true. So I don't know whether actually better optimal performance falls at in terms of n together with the amount of data. That's something perhaps I need to do an extra experiment and then find it out.
Okay. We have another question from Xiao Wang. What were the linguistic backgrounds of the training, test, and reference data?
Okay. I don't have any background information relating to sociolinguistics background, so don't know. So, and also I don't know whether actually the gender of the sex of the authors. So they are all sort of, I don't have any metadata for it. So which means actually not controlled. But genre is controlled, right? Because the platform is the same, which is the Amazon review platform. That's the only thing it is controlled, I think.
I suppose a follow-up that I feel I should ask would be: do you think it would matter if there is if it's a heterogeneous sample or not?
Well, when you are working on the real French kind of situation, you have to think about actually what sort of defense hypothesis you are posing, right? So when you actually, in that case, sociolinguistic information might become relevant. So that's something you might have to think about, but not in this particular experiment. I didn't actually kind of control anything because that's the nature of the database.
Okay, thank you. And we also have a comment from Ayuna. Thank you for this inspiring talk, and I completely agree. And then we have another question from Xiaomin Zhang. What's the essential difference between cosine distance and Hamming distance?
Sorry, I don't know. It's a Hamming distance as in Hamming kind of window you use? Sorry, I'm not sure.
So if you don't mind, I can answer this question. So the cosine would be the angle between the two vectors. Hamming distance is a binary distance that measure how many differences there are between those two vectors, or how many. It's a binary one, right? So whether one if they're actually the same, and zero if they are different. So I don't know if anyone else in the panel feels like they can answer this question, then please contribute. That's what I know. Okay, we have a few more minutes, so feel free to ask more questions if you have them. Can I ask the members of the panel if they have any questions for Shunichi and Maciej?
Yeah, thank you so much. I will have actually a question, which is in a way a follow-up to that by Ariuna, which is about the features you used. You used the range from 5 all the way up to 400, right? And in some of the measures you were using, the performance was worse, right? So this final measures were going up, meaning that this is not very much desirable, right? So the question is, to which extent you can expand the feature vector so that the noise does not overcome or overshadow the signal, right? Is there any way to assess where is this trade-off place, right? When you don't want to increase the feature space anymore.
Yep. Okay, thank you very much for the question. Actually, that's I saw someone would pick up the, I just expected someone would pick up the that point, let me just share the screen back. Sorry. So going back to, yep, that's the, okay, for example, cosine, the performance, just simply just increase, becomes better at a certain point. And then after that, even if we include more features, basically becomes kind of, saturated because it becomes flat. So that's the kind of trend you can observe. Whereas, okay, feature-based method, once you get, optimal performance, after that, with more features, the performance starts deteriorating. So I would expect this is a kind of trade-off between the, complexity of the complexity of the model and the amount of data you require. So there is an obviously trade-off. So perhaps that could be a potential shortcoming of this approach, because the score-based method, okay, the performance wouldn't really change much, even if you include kind of a useless features. But actually, you have to be very, very careful in a sense, what number of the features you want to include for feature-based method to get the optimal performance. That's the kind of trade-off. But I haven't really looked into the kind of how they are kind of trading off. Perhaps that's the kind of something I need to look into.
Yeah, because that was my follow-up question. What is the reason for those features to underperform? Is it because of the zeros? I mean, lots of zeros. The lower you go down the list, the more zeros you experience, right? So is it about the abundance of zeros across the board?
Okay. No, yes and no, but I know the reason why actually, hold on a second. Okay. Okay, I explained that the CLLR is a combination of the calibration loss and also discriminability. So this is what I'm plotting here is that, I'm plotting CLLR mean, which is a performance of discriminability, how well actually you can discriminate same author and different authors type of stuff. So what you can see here is actually discriminability improves, kind of continues to improve as the feature to be added. But actual problem is calibration. So calibration start deteriorating, although CLLR mean discriminability increases. So issue is actually calibration. And what I suspect is you need quite a bit of data to train the calibration model. That is kind of my feeling I have. So for example, if you plot the CLLR curve, which is a calibration loss, it goes or something like that. It's really kind of deteriorate after hitting the best kind of optimal point. So zero is not really influencing much, I guess, in terms of discrimination. But calibration is the one actually causing a bit of problem.
Okay, thank you so much. That was really cool answer. I liked it very much. Thank you.
Okay, fantastic. We have it. According to the program, it's a time for a short break. And unless there are any more questions, and I don't see any in the Q&A panel, I think we can take this break now. And we will resume in 10 minutes with Sheila. Okay, so we're back after the break, and it is now time for me to introduce Dr. Sheila Grant. Sheila Grant is a person who actually should need no introduction. She's as famous as any forensic linguist could possibly be. She's appeared on TV, on radio, and many other media outlets. And that's especially thanks to the massive success of her latest book, Atrapados por la Lengua, which follows actually the other success of her other books that are addressed to the wider public. Indeed, I don't think many other forensic linguists could brag to be so famous to have become a character in a video game, and Shayla can. But the contribution to the field is not just in terms of popularization of the discipline, because Shayla is possibly, without doubt, the most active and successful practitioner of forensic linguistics in modern Spain, where she founded and is now leading the Laboratorio SQ Linguistas Forenses. She also has collaborated extensively with law enforcement agencies in Spain, and so she has a lot of expertise in casework. And today we will all be lucky to hear from her about her experience and expertise in authorship analysis. Now, because Shayla is actually a victim of her own success, we have a recorded talk, and she will actually join us later. So I'll now I'll now share my screen and with the recorded talk.
Good morning, everyone. First of all, I want to thank Dr. David and Andrea for the organization of this second roundtable and for inviting me. Today, I'm going to highlight and raise questions about some of the methodological limitations with which we caseworkers work in authorship analysis. Such important limitations that we may be trying to measure the impossible in authorship analysis, as the title states of this presentation. I would like to point out that in this presentation, when I speak of casework, I mean answering to the inquiries by the police forces, writing reports for legal teams or the judges, and presenting evidence in court. I think this is important since the methodological requirements and also the expert skills are different from those necessary in other contexts, such as in the academic research. Also, yes, another previous warning. I want to say that I am not against probabilistic methods, and the proof is that I dedicated my 4 years of doctoral research to investigating the application of likelihood ratios to authorship attribution analysis. And those of you that know me, you know that I advocate for the need of standardization in this area. But yeah, once I believed that I could contribute to the improvement of expert evidence, but now I think that maybe I was too naive saying what I have been experiencing for the last decades. So the ideal thing for our science, or indeed for most forensic sciences, would be for us to have a large database on the behavior, in this case, the linguistic behavior of the speakers, so that we could extract a series of linguistic markers that would allow us to differentiate between different authors, and these differences or similarities could be measured. This way, we could inform the judges and tell them that this person is not the author of the unknown messages with a probability of 1 to X, because he or she has these particular idiosyncratic linguistic traits that are not found in other speakers with similar sociolinguistic characteristics and in similar communicative contexts. So we should follow 3 main steps as projected here in this figure. Having a comparable linguistic database, identifying a set of core features with discriminant potential among authors, and finally developing a probabilistic model that allows us to determine the probability of a given speaker being the author of the anonymous sample. So the ideal situation would be to have a classification model based on a probability calculation model that allow us to estimate and measure of likelihood ratio. This model could perform the classifications and subsequently calculate the proximity distances between the authors and also between the samples of the same author. If we express this idea more visually, we could have a graph like the following. In blue, we would have the samples of one author, and in green, the samples of the rest of the authors, or let's say the population. All the points in blue would be the text of one author, and therefore the circle could represent his or her, let's say, idiolectal style, and the distribution of the population would be shown in green. That is what the rest of the comparable population does. What is important in order to obtain a correct classification is that the distance between the groups, the red and the green lines, is greater than the distance between the author's centroid, the blue line and the blue cross. That is, to be able to differentiate between the variation within and across speakers, if we talk in linguistic terms, what we call intra and inter-speaker variation. However, we face many problems. Let's start. We do not have appropriate databases of casework. We do not have databases of all text genres in all possible contexts. Furthermore, the vast majority of the corpus that we have, I mean for Spanish and Catalan, are not properly tagged for authorship attribution tasks. Most of them do not include, for instance, sociolinguistic traits for the authors, such as age, gender, educational level, L1. We also have another problem. What is comparable? Text in the same language, text in the same language and textual genre, text of the same variety of language, text with the same degree or formality, text on the same topic. We know that speakers modify or adapt their speech depending on the textual genre, the context, or even the device on which they write. One does not write a WhatsApp in the same way as an email to a friend or a boss, an email on the PC or in the mobile phone, or an email on the mobile phone while sitting on the sofa as opposed to running to ask for help. So, what are the factors that we can do without? We do without the linguistic variety, the formality, the age range of the speaker, the genre, the topic, and can we always do without this, or can we only spare them when we have our sample is of a certain size? I mean, when we deal with any numbers of texts or authors or whatever? Is it true that large corpora or big data are increasingly available, thanks God, especially with texts related to social networks? But are they really appropriate for authorship analysis or only for certain tasks? Can we know what the limitations of those corpora are? Ideally, you should have a list of variables that may have discriminant potential. And in fact, whenever I give training to the police forces, they always ask for a template with all the variables so they can describe the behavior of that variable and that author. And I always have to say that hundreds of variables have been studied and numerous studies have been published, but there is still no universal list of variables that can predict whether two texts were written by the same author or not. In fact, I think it is not a question of why it does not exist yet, but rather it is a question of whether a universal list can ever exist. I tend not to believe in universal applicable markers, although there are some in each level that seems to be stable across genre, for instance. And I know that there is some traits that tend to appear in most of my reports. But I tend to think that more than a list of variables, it is more about the different levels of the language that, depending on the case, provide more or less information. For example, in the case of WhatsApp messages, errors and orthographic choices can be very idiosyncratic, since these platforms promote the creative use of communication resources and allow the development of idiosyncratic uses of language, that is, of the style of the speaker, which is of course beneficial for authorship attribution of this message. However, perhaps if we are analyzing an academic text, morphosyntactic and textual structure variables may prove to be more useful. That is, how the speaker orders his or her ideas and brings them together through different types of sentences and connectors. Therefore, I am not sure that we can have a universal list of core features. I see it more as science fiction than reality. In my experience, each case is unique, and it is very difficult to foresee all the variables that will be relevant to reach a conclusion one way or another. And to continue with this pessimistic train of thought, I must say that I'm generally a very optimistic person, but many of the probabilistic methods, such as likelihood ratios or neural networks, are difficult to explain. And I do not mean that it's difficult to understand how they work. Actually, they are, but that's not what I mean. But that the model is so complex, it chooses so many variables and combines them in so many ways that it's extremely difficult, if not impossible, to know what the statistical model is actually calculating and measuring. And the second and no less important question is, due to this combination of tens, hundreds, thousands of variables that the model creates and combines, it is difficult to provide a linguistic explanation of the results. And herein lies the discussion, actually. It is necessary to be able to explain the model's performance. Do we need to be able to explain the results from a linguistic point of view? Let us take a closer look at how, for example, the software operates. We have said that in many cases, the complexity of the model with the combination of variables becomes impossible to explain. But it's true that despite the fact that in some cases it cannot be explained, it does show an error rate. And therefore, we could trust the model since it acknowledges its reliability. And that is something that right now in qualitative or observational linguistics we cannot have without this type of analysis, maybe. In addition, an error rate is one of the criteria in the Dover standards for the admissibility of evidence in adversarial systems. But we also know that the results of this type of systems depend largely on the number of candidates, the training corpus, the number of texts per candidate, the length of the text, or even the topic. Let's take a look at the data we are dealing with in our laboratory. I have gathered the data for 2021 and until June 15 of this year, and we have issued 11 authorship analysis reports. I have not included sociolinguistic profiling reports as text manipulation or detection of more than one author, or cases in which no reports have been issued because results were contrary to the position of the party, or because they were analysis for investigation purposes only. But well, in these 11 reports, we can see that 91% of the cases, there was only one suspect. That is, only in a single case, we have had more than one suspect. I have marked a case in pink on this table. This case concerns 36 WhatsApp messages, and we had to determine if those messages had been written by the owner of the phone or someone else. We had the WhatsApp conversation, so we had a lot of data, specifically more than 1,700 messages by the owner and 2,400 from the other possible author. So we had lots of known messages, but not so many unknown messages. But we could not complain, taking into consideration that this is far better than the usual scenario. The sources we get the data from vary, although social media, Twitter, Telegram, Facebook, and emails usually predominate. In the vast majority of the unknown data, very short messages were available, such as tweets, and the number of messages was usually between 4 or 7 messages. In the case of known messages sent through social media, such as Twitter or Telegram, we tend to be luckier since we have more data than between 26 and 200 messages. However, in the case of emails that are longer than a tweet generally, but are around 500 words, we do not usually have many known emails from the possible author, generally between 2 and 7. In 2 cases, highlighted now in pink on the table, we had enough data to complement the qualitative analysis with statistical analysis. In these cases, we had a PhD thesis and one written statement. We could implement descriptive and inferential statistic methods, such as ANOVA and Kruskal-Wallis, Oman-Whitney, where and we could not apply methods such as likelihood ratios because we didn't have a base rate knowledge for this text. We did not have previously analyzed corpora, and that we didn't have corpora that should have to be designed at the time of the request. In our particular case, which is a private laboratory, it is very difficult for the client to agree to pay for the creation and processing of a control corpus. When I talk about a control corpus, it's other texts that are written by non-possible suspects, but that serve to measure how rare it is that a given feature occurs. And furthermore, that they didn't have enough time to submit it to the court. In fact, at our laboratory and formerly at the laboratory at University Pompeu Fabra at Forensic Lab, we have regrettably never been able to implement likelihood ratios in casework. And I recall that I said at the beginning of my presentation that I spent 4 years doing doctoral research on this. This has been due to 4 main issues: a lack of unknown or known data, lack of base rate knowledge, the increase in cost of the report, and the time available. In some cases, and with text shorter than a PhD thesis, more classical statistical methods, such as ANOVA, linear discriminant analysis, are implemented, but always with specific variables, such as the number of words per sentence or the analysis of part-of-speech n-grams. So we can only report the results of that specific variable. Okay, let's go to other part of the discussion. Regarding the second large discussion in the field, explanation. In most cases, it cannot be explained how a method with optimal results makes predictions. The method usually performs a multidimensional representation analysis with thousands of data, but we do not know how, for instance, characters are related to words or how neural networks produce their predictions. It is excellent to maximize the performance and obtain great classification results with low error rates. But shouldn't we also increase our understanding of it? Or should we just try and accept a black box? If we cannot explain what the machine, the model, whatever does, in the end, trying to analyze our data objectively might end up leading us to conclusions like, and bear in mind, this is just my opinion, believe me because I am an expert and my machine tells me so. In my opinion, understanding prediction should not only be a goal, but also a responsibility of the researcher, in this case, the expert witness. We cannot intend to inform a decision maker or a judge as experts about something we do not understand ourselves and hope that he or she makes a decision about someone's life based on something that he or she doesn't understand and that we as linguists don't know how to explain. I understand that computational linguists or scientists may overlook the lack of explicability or may not consider it the focus of their inquiries. But I think that linguists, experts who inform the police or judges should regard this issue as central, and perhaps if more joint studies were carried out, we would come up with models for which better, I'm not saying whole explanation, but better explanations could be proposed. In the first roundtable, Dr. Grant, I indicated that if we wanted to meet those criteria and base our work on theory, we should not use a theory about language, but about authorship attribution. For example, asking ourselves why different authors vary their style, and why or if an author has a stable style across the different textual genres. In Spain, where there is an inquisitorial justice system, as well as in Latin American countries in which I present expert reports, and I have presented them actually also to the court, what is given more weight in the process of deciding on the admissibility of the evidence is the recognition of the expert rather than the method used. However, after more than a decade acting as an expert, I have always been asked about my qualifications, but also about the fundamentals of the discipline and if the methodology followed in the report is the usual one in this discipline. So I dare say that the criteria relied on by the court to consider report is the rigor and systematicity. And I say this in capital letters. It is a combination of both factors, as well as their performance in the courtroom, that seem, in my opinion, to convince the court of an expert credibility, intellectual rigor, rational explanation. In these systems, and I always speak from my experience, those experts that are presenting analysis which the judge perceives as not sufficiently clear are not finally fully considered or considered by the judge in order to make an informed decision. So, knowing that written text authorship attribution is a complex task, since any linguistic co-production implies certain degree of operation in the use of language, can we carry out authorship analysis? Well, I think so. Otherwise, what am I doing here and in the laboratory? But the linguistic study in this type of expert analysis consists in identifying the set of idiosyncratic linguistic markers present in the analyzed text that allow us to determine if the known and the unknown samples display features compatible with the hypothesis that they have been produced by the same person or not. In the cases I work on with text in Spanish or Catalan, and given the current states of authorship attribution, especially regarding instant messaging, it is not possible to individualize. That is, it's not possible to distinguish an individual from any other member of the population. And what we generally do in this type of case is a stylistic analysis. This type of analysis is based on the variation between specific individuals in relation to qualitative linguistic markers. In this analysis, this variation is explained as the result of the choices that the authors regularly make among a wide range of linguistic possibilities. This way, linguistic choices present in the analysis of the unknown data are identified with their corresponding orthographic form, and the known text and selected linguistic markers are then examined in detail to determine if there are features that can consistently distinguish the two authors according to the linguistic choices present in the known text. The list of identified linguistic traits, however, should not be interpreted as exhaustive lists or as linguistic traces that can identify each of the speakers among the population to which they belong, but rather as samples of the relative coherence and regularity of the language choices, and can therefore be used to distinguish between these speakers in the case using a qualitative analysis or even using descriptive statistics. Therefore, knowing all the limitations, we can continue doing, in my opinion, authorship analysis with a closed set in a particular context, and with that we can reach a conclusion based on a probability verbal scale. In my opinion, and based on my experience as an expert, statistical methods cannot be applied very frequently due to what I discussed above. And if they are applied, they should be understood as a lamppost on which you can lean, but we cannot rely solely on an unsupervised automatic result, and even less so if we cannot understand how the result has been obtained. Therefore, there are 4 points that I would like to highlight to end my presentation, and I think are of vital importance to present evidence in court. First, we must be able to explain the results from a linguistic point of view. Otherwise, we are asking the judge to make decisions based on faith in the expert and his methods. Second, a statistical analysis should be used to validate qualitative analysis, but in no case should they be used in isolation. In some cases, the difference or similarities indicated by the statistical text can be perfectly explained from a linguistic point of view. For example, because the level of formality is different, because there are 2 different genres, or because the purpose of the speaker is different in that sense. Third, the implemented techniques must have been tested previously. We cannot come up with a technique for a particular case. I mention this because I have come across several reports, not 1, not 2, not 3, in which this was the case, and they have also indicated in the report that they use a software for the first time and that they have developed it specifically for that case without testing it previously. Fourth, linguistic variables should be mentioned in the report. Yes, surprisingly enough, I have been reports that did not explain what the statistical model analyzed. And finally, and I finish here, we need to be able to explain clearly the variables analyzed to reach a conclusion. We cannot inform the decision maker or the judge only with our conclusion. A rational decision maker cannot be expected to base their decision on faith. I hope this presentation raised a lot of comments and questions and make us think and work in interdisciplinary teams to get better explanations on these statistical models that are proposed. Thank you very much.
Okay, so Sheila will be able to join us only in the afternoon. Oh, here she is. Sheila, are you available to answer questions?
Yeah, no problem.
Okay, good. Right, so if there are any questions for Sheila, then please use the Q&A tab. And we have only a few minutes, but of course there will be plenty of time for discussion later on. And I mean, I have a few questions, of course, but they are probably, okay, here it is. Here is one that's probably shorter than what I want to ask. Tina is asking, do you report in terms of likelihood ratio or verbal scale?
No, I do not report on likelihood ratios. As I stated, we have never applied likelihood ratios in expert reports.
So do you use a verbal scale of confidence?
We use a verbal scale on probabilistic, stating that there is a high probability, a medium probability, that it's the same writer or not.
Okay, thank you. Isabel is asking, can you expand further on what you said that the methods used should have been tested previously? What methods? The statistical?
Yes, exactly. I have come across several reports that they have implemented a software. They have created a software, and they just stated that they have used it for the first time on that report, and it was specifically created on that report. And normally it's computational methods based on
Okay, I think we might have Lost Sheila.
this software, and they have never submitted anything.
We lost you a little bit. Can you just repeat the last few sentences?
Yes, that they stated in the report that it was the first time that they have used that software in which they analyze normally word n-grams. And they stated that it was just created for that report and never been tested before with other data. And I have been following them to see if they were submitting some scientific articles on the tool, and they have never submitted anything.
Okay, thank you. And we have Shunichi who would like to ask a question as well.
Yes. Sorry, I just rejoined because anyway. Yeah, thank you very much for the interesting presentation. Just question about explainability. Okay, when we had a presentation by Professor Stamatos, I don't really remember exactly what he said. Basically, what he said is something like that. Currently, he and his. Can you hear me?
Yes.
Yeah. Okay. They don't really pay much attention to the explainability. Just following up onto it, I actually gave 3 points in order to comply with the admissibility criteria, in which basically explainability is not included. So, but we are not really neglecting it, but it's not really kind of not most important, probably because, but instead, forensic scientists really, really serious about validation, particularly under forensically realistic condition. That's something, they actually focusing on, because because forensic science, it's difficult to explain things to lay people. That's the starting point. And you need a degree. You got a degree, and what you're doing is very difficult to explain anyway. So that's why validation is extremely important. That's the kind of standing point they are standing. And because, for example, for DNA, which is a golden standard, I don't think lay people would understand it, the procedure and analysis, that sort of stuff. So that's something perhaps I can I can say, but very serious about validation. Not just the validation previously, but under forensically realistic condition. Under the condition you are working, under the same condition as the case as you are working on.
Okay, excellent. Thank you very much. So of course we would like to hear from Sheila and then also from the other members of the panel, but we can for these wider issues and discussions, we'll just do that during the roundtable discussion later on. And we can now, I'll now leave the floor to David, who will introduce James.
Thanks, Andrea. Yeah, I think can you hear me okay? I think Sheila's talk has raised a number of broader issues which might be useful to talk about in the bigger discussions. Pardon me. So next, then, it's my pleasure to introduce Dr. James Tompkinson. James is a forensic speech scientist who holds a PhD in linguistics from the University of York in the UK, which is just down the road from where I'm sat now. We always, well, I certainly do, in forensic authorship analysis, look across to forensic speech science for a number of things in terms of principled methodologies, means of expressing evidence, feature identification, and that's why in this roundtable and the first one previously, we always like to have our friends in forensic speech sciences represented, and I can think of no one better today than James to do that. James's PhD is, his research is particularly focused on listeners' perceptions of spoken threat utterances and ear witness voice descriptions. But since then, and alongside that, James now works as a forensic consultant and caseworker at the famous JP French Associates. So without any more from me, we're very lucky to have James here today, and over to you, James.
Thank you very much, and thank you for that very kind introduction, for inviting me as well. It's a pleasure to be here, and I just wish we could all be together in person, but you know, such is the way of the world. So I'm going to try and now get to grips with the technology and just share my screen to make sure that you can see everything. Can you?
Yes, that's perfect, James.
That's perfect. All right, brilliant. So yeah, firstly, thank you very much for having me. And as David said, I'm coming at today with my kind of casework hat on. So I'm going to be talking about things that are relevant from my experience of doing casework in forensic speech science. Start with a slight disclaimer that there's going to be not very much kind of data in this talk. It's going to be sort of an experience-based talk, but I'm hoping that what I'm going to be able to do is raise issues that are relevant not just in forensic speech science, but also across different forensic disciplines, and with kind of an eye towards authorship analysis. And then hopefully, you know, in the discussions, we can think about these kind of broader issues and think about how, you know, what I think about certain things might relate to other disciplines. And I'd be very interested to hear the reverse as well, which is, you know, sort of why I'm going to raise some of the points. So what I'll do, I'll talk a little bit about key tasks in forensic speech science, just to kind of give you an overview of the sort of work I'm talking about, and then specifically a little bit more on forensic speaker comparison, just because that's the most natural parallel with authorship analysis. And then really the rest of my talk is going to focus on two key questions. So how do we make our evidence appropriate, and how do we make our evidence understandable, which I didn't plan this, but should link quite nicely to the first two talks. So that's a bonus. And then obviously, hopefully there's some time for questions and discussion. So the sort of work that I do, you've got four kind of broad key tasks within the work that I do. So you've got speaker comparison analysis, which is trying to answer the question, you know, can you compare the voice of speaker X to speaker Y with a view to saying, you know, an estimation of likelihood as to whether they're the same person or not. Linked to that, you've then got something called speaker profiling, which is where you just have a recording and it's what can you tell us about this speaker from the way they talk? And then sort of two separate but related tasks to each other. Transcription, which is, as it suggests, you know, can you tell us what's been said in this recording? The recordings that we work with in transcription are often, you know, fairly noisy or difficult, or there's some reason why they might be difficult to hear that needs sort of some expertise there. And then something called disputed utterance analysis, which is where you might have a certain section of a recording and it's kind of, can you tell us what's been said at 3 minutes 53 in this recording, or we think we can hear this, is that right? That type of thing. And those are kind of the broad tasks that I deal with in the work that I do. But given that the roundtable today is going to kind of has an authorship analysis focus, I'm going to talk a little bit more about forensic speaker comparison, because this is kind of the most direct parallel with authorship analysis. So forensic speaker comparison work, and for those that don't know, it's a comparison of the voice of a question speaker with the voice of a known speaker, or multiple question speakers with multiple known speakers. And what we're trying to do is assess the strength of the evidence for or against the view that the known speaker and the question speaker is the same people, the same person. Now, in my case, what I do is I do my work using what we call the combined auditory and acoustic method of analysis, which is a slightly fancy way of saying I listen to stuff and I measure stuff. So auditory analysis would be listening to the way that certain sounds are pronounced, making IPA transcriptions, and thinking about voice quality, which is sort of the overall kind of character of the voice, whether somebody's got a very creaky voice or a nasal voice or a harsh voice or something like that. And then acoustic methods are things for measurements of things like pitch, so how high or low pitch someone's voice is, things like form measurements, which relate to vowels and speakers, the way that speakers pronounce vowels. And then we'll also look at other things like disfluency patterns, so ums, false starts. As soon as you say this in any talk, I realise that I start every sentence with the word so and say a lot. So that's going to probably something you'll notice now, and that's the kind of thing that you might pick up on. And keywords, if certain people using certain words and phrases and that type of thing is something we can analyse too. So there's quite a diverse kind of set of things that I'm able to look at when I do this, and that's good. But then also for you combining all these analysis into kind of an overall conclusion. Okay, so my first kind of question is, how do we make our evidence appropriate? And I'm gonna lean a little bit on this document, which is something that was produced by the Forensic Science Regulator in the UK. Now, I have to be honest, this talk is going to be UK focused, but hopefully still has kind of appeal to people that work in other jurisdictions. But it's a document that came out this year, and it talks about standards and development of evaluative opinions, which is relevant, and it actually lists authorship analysis and it's relevant forensic speed comparison analysis too. So kind of a document that I'll talk a little bit about as I go through. But what it has in it is it just kind of outlines for people that are doing this kind of work what their roles are and how they should work, and I think it's really good. So I would urge people to go and have a look at it if you haven't already. It picks out key things here. So the job of an expert is to provide expert evidence within their area of expertise. That's should go without saying, but it's important. And then kind of just, I think, linked to what Sheila was saying in the last talk, to be able to assess the value of the observations that you make and then present that evidence in a nice, clear and consistent way. And the point of an expert witness is to provide evidence that the court, that wouldn't be understood by people otherwise without you there. So, if a jury, it says here, if a jury panel is capable of dealing with issues themselves, then you don't need an expert. So that's the point of why you bring experts in. Okay, so I've got 4 points really under how do we make evidence appropriate. First one is expressing conclusions. Second one is to do with check-in. Third, about cognitive bias, which was also mentioned this morning, and then a couple of other issues that I just want to raise that might be interesting for discussion. So the first one is expressing conclusions. Now, across forensic science, there are different ways to express conclusions, whether you go for something very statistical and numerical or something more kind of on a verbal scale. And really what you choose will be kind of dependent on the analysis that you're doing and the quality of the data that you've got. Now that's broad level, that applies across forensic science. But in that document that I mentioned, they talk about the kind of the differences here that you get and what's the most appropriate. And it's worth having a nod to this that says that actually, obviously in a perfect world, we'd have lots of really high quality data that would be relevant to every analysis that's done, but often that isn't the case. So experts can rely on things like, published material or their own expertise or their own experience in helping them form judgments about that then feed into the conclusions that they give. And this kind of document sets out a space and a framework in which that can be done. But there are two key principles related to the expression of conclusions, certainly, and I'll talk about this from a forensic speech science point of view, but I think this is relevant kind of across. Some of this was already mentioned this morning, but issues about similarity and typicality, and then having a range of possible conclusions which can reflect the findings that you have. So we'll deal with similarity and typicality first. So similarity, quite as it says, how similar the features in the question and reference samples. So you've got two profiles for two voices. How similar the features in the known sample and the question sample? Are they similar or are they different? Now, that sounds kind of straightforward, but sometimes that can be, it still requires some judgments about things, because, for example, you would, even in cases where you reach a same speaker, so suggest that there's some support for a same speaker conclusion, actually, you can still have differences because voices are variable. So, for example, if you've got two samples and let's say that you've got, I don't know, somebody and they're speaking really loudly down a telephone and you're comparing that to a really mumbled police interview, well, you would probably expect there's a predictable difference in something like pitch, because you raise your pitch when you speak more loudly. And so you would expect a difference there. But if that difference reflects the samples that you've got, and you can account for that in your conclusions. So they're the type of things, that we're looking at when we think about similarity. And then typicality. So how common or unusual are the features that you find given a relevant reference population? I'll talk a little bit about that in a second. So you need to sort of consider these two things, similarity and typicality. So here's a hypothetical example. So let's suppose that we've got a voice comparison case, and I've got question speaker X and I've got known speaker Y, and they share, so let's say both speakers, and I've put this here, share monophthongal realization to the face file. Now you're probably thinking, what the hell is he talking about? But what I mean by that is, there are lots of different ways to pronounce the A vowel in words like face, and particularly across British English, right? That vowel varies an awful lot. And you can have a realization that something a bit like face, which would be a diphthong, where you've got movement of the tongue through the vowel, or you could have something like face, which would be a more steady state vowel, and that would be an example of the monophthongal realization. So let's say we're working with two speakers, and they both say the A vowel in words like face as a, so face, something like that. Now, let's imagine then that's a similarity, that's fine. But if the range of other features that you got suggest that those speakers are from West Yorkshire, that's really typical, right? Loads of people do that in West Yorkshire, so you wouldn't assign as much weight in there. But if you've got two speakers and they all both have other shared similar features of an accent in which those vowels aren't as common, then that would be more unusual or atypical. So depending on the combination that you've got, depending on your assessment of the speakers, depends on how much kind of what you'd assign weight-wise to the features when you're sort of concluding everything, really. Here's another example. So that would be an example actually from kind of an auditory perception, transcription of vowels type analysis. Here's one from a measurement point of view. So here's actually some statistics that was from this paper by Hudson et al. In 2007, and they plotted mean F0, which is pitch measurement, so how high or low pitch. It's just a measurement of how fast the vocal folds are vibrating in the larynx. And they plotted that for 100 speakers of Standard Southern British English. Now you can see here there's a range of values, with kind of the most common ones being somewhere between, let's say, I don't know what, 101 and 111. So if you've got two speakers and let's say that the speaking style and the speaking level are similar in two samples, and you had two measurements and they were, I don't know, 106 hertz. Well, that's going to kind of give you, so that's a more common finding than if they were 75 or 150. For if it were male speakers, of course, female speakers would be different. So you're thinking about these two things all the time: similarity and typicality. And then to talk about conclusions. Now, I'm following on from Erica's talk last year, which is a fantastic talk about likelihood ratios. So I'm not going to go over all the stuff that she talked about, but I think on a broad level, what you have to think about when we're coming up with conclusions in cases are the two competing propositions or hypotheses. So if it's a forensic speech science case, either the known speaker is the question speaker or it's somebody else. They're the only kind of two truths that you've got there. And I've put in brackets there who speaks with a similar accent, which is relevant to that relevant reference population that we talked about before. But it's also possible to have kind of more specific propositions depending on the type of case that you've got. So I think Sheila mentioned open and closed set comparisons. So here's an example from a forensic speech science case where you might have more restrictive set of speakers who it could be. So an example of a closed set, something like a recording that's made in a car where there's no dispute over who was in the car, but there is dispute over who said what. And then therefore the potential other speakers for your comparisons can only come from the people that were in the car, as opposed to anybody. And the last point here is also probably the most important thing. It's really important, I think, to think about the scope of the evidence. So voice comparisons don't produce matches. It's not like a CSI effect where you go, oh, that's definitely him. Well, actually, it's not like that. You have to evaluate your evidence properly and make sure that you're not overstating the value of it, and that's crucial. So in my case, what I do is I use a verbal likelihood ratio type scale, so verbal scale, support scale for expressing evidence, and it's a balance scale which has different levels of strength of support for either the view that the question speaker is the same speaker as the known speaker, or that it's a different speaker, and with an inconclusive in the middle, which would be doesn't provide support for either view there. And it allows you to balance up, the strength of your evidence, and then present an appropriate conclusion to the end user, so to the courts, basically, with a range of possibilities. And even, and this I think is important for emphasizing that you're not ever going to say, oh, it's 100% definitely the same speaker. Just depending on the features that you've got, the analysis that you can do, it lends a degree of support to either the view that it's the same speaker or the view that it's a different speaker, and balancing those up. Okay, so that was a little bit about conclusions. I'm going to just talk very briefly about check-in. Now, this is taken from the IAFPA Code of Practice, which says that it's recommended that members have their analysis and written reports reviewed by a second analyst with relevant expertise. However, it's acknowledged this might not be possible in all cases. Now, this is where the practical element of work comes into it, because sometimes there isn't a second analyst that can check work. But I think wherever possible, it's something that we should try and move towards and strive to do, to have your work checked by somebody else, for them to come up with a set of conclusions for the case independently of you, and then to discuss and kind of agree those conclusions. The reasons why I think it's important and it's good is because it promotes accountability and transparency. It reduces the chances of an error being introduced. If someone's made a glaring error or a big mistake or something, then that's more likely to get spotted. Promotes discussions around conclusions and appropriateness, and I think it helps the expert and reinforces confidence in what they've done too. If another qualified expert's had a look and said, yeah, we agree, then it gives you some kind of confidence as you move forward through the case, and as that evidence then goes into the courts. And so I think check-in's a really good thing, and I think it's something that we should be promoting wherever at all possible, should be a standard that we should aspire to, personally. Bias was mentioned this morning as well, and I think that, again, this is taken from the IAFPA Code of Practice. Sorry, for those who don't know what IAFPA is, it's the International Association of Forensic Phonetics and Acoustics. I've probably said that before. Where it says members should take case-appropriate steps to mitigate the effects of contextual and cognitive bias. Now, in casework, forensic casework, there's loads of sources of potential bias. So this could be things like case-specific information that you're told, that could sort of unduly, have a potential to bias you one way or another. Being provided with evidence in a case pre-analysis, or if it's something like transcription, say you've got a recording that's coming for transcription, but at the same time you look at a different transcript, like a transcript that's been done by somebody else, that might then prime you into thinking that you can hear things that you maybe wouldn't have done if you'd done them blind. So it's important, I think, to develop strategies to try and mitigate the effects of this wherever possible, and having an awareness of bias. I think it's important to acknowledge that there are always going to be potential for biases in forensic casework, and it's our job, it's the job of the expert to try and mitigate those, or wherever possible. I think that's and having kind of developed strategies and ideas and things you can do to mitigate the effects of bias, I think is very, very important. And maybe that's something we can talk about in the discussion about how that might actually work in practice. And then some other issues to consider. So assessments of suitability and developing strategies for what I would call a pre-analysis assessment of materials. It's the nature of forensic speech science work and forensic work, I think, generally, that sometimes you don't always work with really good quality materials. So the recordings that you can get can be often really poor quality. They can be short, they can be, have lots of background noise and things like that. And sometimes, it is just the right outcome. The most appropriate thing to do is to say, no, I can't analyze that. They're too poor, and to make sure that kind of that you've got some strategies for dealing with that. Helping with the development of the field, maintaining an awareness of research and forensic publications and documents, I think, is crucial. That's why things like this roundtable are so good, because it promotes discussion amongst practitioners and researchers. I think it's brilliant. And something just I'm going to stick on the end of this, well-being and mental health, I think, is also really important. Don't take these things for granted if you work in casework. Forensic materials can be difficult sometimes; they can be unpleasant. It's important to have an awareness of those things, and I will keep saying that in talks that I keep giving, because I think it's hugely important. And I'm just going to take a few minutes. I know I'm short, nearly at time, but just to talk about the second part of this. My two questions, which is, how do we make evidence understandable? Now, this links almost directly to what Sheila was saying in her talk. I think it's really important that when we are doing casework and working in this world, that we think about who it is that needs to use the evidence that you're given. So it's important that whoever is the end user, they are able to understand what it is that you're saying. And I think it's particularly important for language and speech, because, and I've heard this said by lots of people at different conferences, it's certainly not my line, if you like, but the idea that, because everyone uses language and everyone speaks and everyone thinks they can tell where people are from, and everyone think, that it's something that perhaps it needs a little bit more careful kind of explanation from an expert as to why both expert evidence is needed and relevant and important. So I think that by constantly thinking about who it is that needs to use the evidence, that frames how we communicate and how we tailor it. So things like people like judges, lawyers, jury members, instructing parties, they all need to be able to access and understand the evidence provided. But at the same time, there also has to be enough detail in your evidence and your reports for potential other experts to come in and look at the results and the findings, and that kind of thing as well. So there has to be a balance, I think, between, thoroughness, accuracy, and understandability, transparency. Reiterate again, the reason why we're giving expert evidence is because we're dealing with something that members of the jury aren't capable of dealing with without assistance. So there is no point in giving expert evidence if you can't help the jury. That's your job. Your job is to help the jury. You've got to make your evidence, I think, understandable. Otherwise, the jury won't understand it, and then you're not performing your duties properly. So in reports and in courts, the most common way to present findings through a written report, that can be used as evidence, or you could be required to go and give evidence in court. Now, there's lots of guidance about what should go in expert witness reports. Some of that is legal guidance, some of it is subject-specific guidance, depending on what it is that you do. But I would just say, reiterate the need for precision and clarity, really careful use of technical language. So if you're going to use technical language, make sure you explain what those things mean and make sure it's understandable, and obviously make sure your reports are accurate. And then for oral evidence, I think it's really important to try and find a way to explain findings without using too much technical jargon, because you're talking to people who don't understand the complexities of discipline that you're dealing with. And to bear in mind all the time that, our role as experts is to help the court understand the evidence, and your job is to act really as, I think, as an independent and impartial advisor to the court. And I think if you kind of keep that in mind all the way through, then it's a good place to, it can get lost, I think, a little bit. I think it's a really important thing, and it's not something that we should lose sight of at all. I think it's the most important bit, that you have to make sure that what you're doing is understandable by the people that need to understand it. So that's all I've got, really. So just to reiterate again, thank you very much for inviting me, and thank you very much for listening. And if you've got questions, I'd be more than happy to take them, or to take some of these issues perhaps into a discussion later on. But yeah, thank you very much.
Thank you, James, for that. Very interesting talk indeed, and precisely the sort of thing I was personally hoping for when we invited you. We have, let me just check, we have some, so this is where we have to split the time. So we have 10 minutes for questions that are just for James, and then after that we have until 12 o'clock where we can, the first opportunity, or one of the first opportunities, to broaden out and try and maybe bring some of the threads that have come through the talks already this morning and speak to those. Up to now, the questions have all been asked in the question and answer function on Zoom, which is great. But if anyone wants to ask a question verbally, then by all means put your hand up, and I think I have to then allow you to talk, which is an interesting way to describe it. So, Lynn, you have a question, so I'm going to come to you. Oh no, you can unmute yourself. You have one of those privileges, so thank you very much.
I have this privilege. Yeah. Well, thank you, James, for a great talk.
Thank you.
I thought it was very interesting, and one important observation you mentioned is that there's also variability within speakers, so that the people you look at, I mean, depending on the circumstances, they have higher pitch, lower pitch, and also in other features. I imagine it's also related to what I did in my dissertation, but and that I will be talking about later. So I was wondering, do you have any specific strategies of dealing with variability and variation within speakers?
Yeah, I mean, you're absolutely right that one of the problems, the complexities of voice evidence is that, you know, people, there are lots of ways in which voices vary, so they can be kind of, you know, even if you just think about something as broad level as, you know, the way I'm talking now in this setting to the way that I would talk to, I don't know, my brother if we went to the pub or something, you're gonna have differences. But I think it's important to think about, there's, I think, two kind of broad strands of differences. So there's kind of what you might call predictable differences based on what we know about speech in different settings. So that would be things like I mentioned, like pitch in raised voice. You know, if you've got a recording that's where somebody's really raising their voice, then their pitch is going to be higher than it would be if in an interview type setting. And then sort of more, so variation that's more centered around, like, I don't know what you might class, if you call it sociolinguistic variation, or the sort of variation that depends on the speaking style, that type of thing. So just having an awareness of it and an understanding of it, I think, is the most important thing, and being able to work out where differences go beyond what you would expect for natural variation in speech. Because if you flip that round, I mean, variation can also help you understand similarities and differences, right? Because think about the example of people raising their pitch when they're talking on the phone. Well, let's say that you've got raised telephone speech against an interview, but the speaker's pitch was higher in the interview than it was in the raised telephone speech. Well, then that tells you quite a lot, because you would expect it to be the other way around. So you can use what we know about variation to help inform kind of the decisions that you make and that interpret the findings that you've got. And it's just having, I think, a really thorough critical awareness of it, and being able to try and think about those things as you do the work, and they're going to affect different features in different ways, which is part of the complexity / fun of dealing with voice analysis.
Yeah, thank you. That sounds good. Yeah, indeed, taking into account the fact that, well, being aware that these differences exist and that you can actually use variation or this idea to get to other conclusions. Well, thank you.
Thank you for that question, Lynn, and for the answer, James. I suppose that the example that you use about talking here and then talking in the pub is similar to what Sheila was saying earlier about genre variation in written authorship analysis as well. There's obviously similarities there. Thank you. We've got a couple of questions in the question and answer chat, so that's good. We have a question here from Marcia, who says, "Thanks, James. Hi, James. Thank you for this talk. How do you yourselves make sure that irrelevant contextual influences cannot bias you? Do you do blind analyses, or are you planning to apply that?"
Okay, so it's a really good question, and it depends on the task, really. So I'll take transcription as an example. So if I was transcribing a recording, I would always want to do a blind version of the transcript before I looked at any, or even several blind versions actually, before I looked at any other transcripts. So, like, I don't know, let's say that, you know, I suppose you've got a case in which there's a police transcript, or a transcript's been done by somebody else or something like that. I would always want to do my own first, so that and keep those, you know, as documented like drafts, so that I know at which point, if I come to something and I look at it later, I know that I've got a version that was, no, I did this sort of independently of any information. I try and avoid, wherever possible, looking at information about the case until the point at which I've got to some conclusions, because sometimes there's information that can be relevant and you need it at some point. But I think it's just a case of when you introduce it often is the case. So making sure that you're happy that when you're introducing other information that you're doing so in a structured and documented way. So sometimes blind analysis, sometimes sequential and masking of information just really depends on what it is that you're dealing with. But principally, the more analysis you can do without knowledge of information, I would say the better, and then you can then choose what you introduce and when, and then you've always got a record of what was done blind, which is probably, I think, the way to go, which is like a balance between practical and appropriate and right.
Thank you, James. I know Tim Grant and others recommend the same about knowing as little as you can about the details of the case before conducting the analysis. So that's a little bit of similarity there. We have a question from George Brown. Thanks for the talk, James. In your view, what constitutes a good / sufficient / robust checking protocol in forensic speaker comparison?
How long have I got again? I think I think the thing about checking is that it kind of should do two things. So I'll put my hat on as if I'm checking a case for somebody else. I think enough of a check of the findings to make sure that they are accurate and that representative, make sure that things haven't been missed. So there's two types of that. I suppose you can check what's been done, but you can also make sure that what's been done is thorough enough. And then I would say that coming to a set of conclusions as the checker independently of the analyst, documenting those, and then coming together and talking about them and discussing them to see if they're the same or different. And that, I think, I would say that approach is probably a good approach to checking, doing those kind of three things. Yeah.
Okay, thank you. We've got, thanks for that, James. We've got 3 questions in the question and answer panel, but they're nice ones because they blur the lines, I think, between questions that are just for you and questions that I think speak to some of the broader issues that have been raised by the talk so far. So, James, and James, first of all, James, don't feel like you're under a lot of time pressure to answer these in 2 minutes. But also, if anyone else at this point wants to contribute or raise their hand or make a comment, then please do. The first comes from Jeremy Robson. Thanks for an interesting talk, James. In your and this is certainly to be answered as well as by James by other people in this roundtable who've had this experience. In your experience, from discussions with lawyers and in given evidence, to what extent do you think that the legal profession understands the limitations of the conclusions that you draw? So that's a nice question there for you, James, and others.
Yeah, I mean, I don't mind having to go first. I mean, I did think that you're always running the risk, aren't you? If you talk about making evidence understandable in a talk, if you're not then understandable, then there's a problem. But I think that I suppose the short answer would be it depends. But I think that what I was trying to get across in the talk, and I do actually believe this, is that the onus is on the expert. So it's your job to make it understandable, and if you don't think that in a particular in a case or a particular set of circumstances that somebody isn't understanding what you're saying about your conclusions, then it's up to you to find a way to do it. You can't assume. I don't think this is the problem, right? You can't assume that everyone is going to understand everything, and it might be that one set of jurors and lawyers understands what you're saying perfectly, and a different set might not. And it might be that you then have to find another way. But I think that I just think that's part of the job of an expert to be able to find a way to make what you're saying both accurate, but also technically accurate and discipline specifically accurate, but also understandable. And I don't think you can just assume that, for example, oh, I said this one way in that case and it worked, therefore I'll just do that every time. You know, obviously you develop strategies, but I think that it's just up to you. And I think that, you know, talking to people and finding ways to explain is probably the most difficult thing. But it's just, you've just got to do it and just find a way. And it might just be that you know, there are different ways for different cases in different sets of circumstances. So yeah, interesting to see what everyone else thinks though.
Well, actually, yes. Nice attempt there, James, to give everyone else the floor. I appreciate that. There is a, Tina, I can see your question as well, so I've not forgotten about it, but I'm going to ask Chris's first because it links to what you've just been saying there, perhaps, James, to ways in which you attempt to make that communication as clear as possible. And the question is, regarding communication strategies you use to convey technical information to laypersons in the courtroom, do you overtly talk your audiences through that rubric for evidential strength that you showed in your slide? And what's your opinion on using analogies or metaphors to help communicate? Chris then ends with, I know that the fingerprint metaphor is popular but contentious. So I'll leave that one with you, James.
Okay, so the first part of that, yes, you can. I do overtly talk through the range of possible conclusions, because I think it's important for, if you're going to come to a conclusion of, I don't know, let's say moderate support for the view that it's the same speaker, then it's important that the jury and the court understands where that comes from, you know, and the fact that it's not just come from nowhere. You know, it's part of a range of conclusions that you could have come to, and you've chosen this one for these reasons because this is what the analysis suggests. So yes is the short answer to that one. And then the metaphor one, yeah, you can do it, but again, I think it's that balance of technical correctness and then the way you explain something. So if you're going to use a metaphor that is gonna in some way, I don't know, misreflect or put the evidence across in a way that might not be correct, then that's no good. But if you can find ones that you might think, oh, I can draw an analogy here, or I can say it this way, which might mean that somebody understands it a bit more clearly, then I think that's fine. But I think you're always trying to walk that line between, you know, making sure that what you're saying is accurate, correct, proper, but also in a way that then can be understood. And it's not easy, but I think that it depends on the metaphor. But I wouldn't personally use one that involves fingerprints.
No. And thanks, James. And one more question. This is probably quite specific to you, but it's about likelihood ratios. And it's a shame that Shayla's not here because for this discussion, because she referred to these as well. But of course, there are other people, notwithstanding our first speakers, who can speak to this as well. But Tina has said, it seems you're very close to reporting a likelihood ratio, but you're not quite. A likelihood ratio is comparative. The findings are more likely under hypothesis 1 than under hypothesis 2, for example. Do you choose another wording because your again, we come back to the communication to audience. Do you choose another wording because your audience has difficulties with actual likelihood ratios, perhaps?
I mean, the scale that's used is designed, I think, in such a way that it has that kind of, I don't know what you might call it, like it's balanced on both sides. It reflects both hypotheses, both sides. So in that sense, yeah, it's doing that job. But I think also it's not, what we don't go as far as doing is doing numerical likelihood ratios for lots of different reasons. Some, you know, but to do with kind of the analysis that we're doing, it's you know, not there yet, really, I don't think, for this type of analysis. But certainly in the way that it's certainly combine it with this method, you know. So it's a bit of both, really. But I do think, going back to the kind of second part of what you said, is that and it's actually talked about in that document that I mentioned, sort of that you know, words can sometimes be easier to understand, and you know, I think that having something that is laid out like that, where you can show the range of possibilities and you can explain where your conclusion comes from, is important. So you know, thinking certainly in that framework of, you know, the two competing hypotheses, and where does the evidence, how much support is there for one, is important. And then, you know, the scale is a way of communicating that, both, again, that walks that line, I think, between accuracy and ease of understanding.
Lovely. Okay, so that was the end of the questions for you, James. So well done there. You've done more than your shift there.
Sorry to interrupt. So I'll just move the visualization so that all the panelists can be seen by the audience. Okay. All right. So yeah, we can just open the floor to general questions and or comments from all the different perspectives we see now. For example, I don't know if any of the panelists would like to offer their views on the previous talks by James and Sheila. I would like to ask a quick question, actually, precisely following up the last comment that James made. So James said that forensic speech science is not there yet with likelihood ratios. Am I quoting you correctly? And I would like to hear, I don't know if Shunichi can contribute, perhaps, because I know that there is a lot of work in, I think there's definitely more work on likelihood ratios for forensic speech science and authorship identification. So, yeah, I don't know if you can.
Yes. Yes. Thanks, James, for a nice, explanation of the current state of the forensic voice comparison, forensic speech comparison. My understanding is a bit different, because I'm just thinking about Peter and Erica's report of the current survey of the approaches for forensic voice comparison, in which my understanding is actually likelihood ratio based approach is the most popular one, including both numerical and also verbal scales. That is my reading of the paper. But at the same time, as a person who knows the UK position statement very well, which was published in 2007, I recall, from that stage, from that approach, there was a bit of a discussion between those who are working on forensic voice comparison and also those who support the UK position statement and the related approach. There is a big change to me, shift more towards likelihood ratio type approach.
Yeah.
So, to me, the likelihood ratio based approach is the most popular or widely used one. Am I wrong?
No, I think that's exactly right, and it's probably my lack of an explanation. What I meant was, I think that, so there's the likelihood ratio approach, whether it's, like you say, verbal, it's yes, and that's where we are. That's exactly that's what the scale is doing, where we're using. So yes, thinking in that way and using that, absolutely, yeah. I was thinking more just on the lines of just a completely numerical sort of system based on, and also it's method specific too, right? I'm talking about based on the method that I'm using, which is the auditory and acoustic method of analysis, but certainly to use the framework of thinking, in the way that thinking in terms of that likelihood ratio framework is where I would be, so perhaps my lack of I don't know, perhaps didn't say that quite properly in the last part of my comment, but I would agree.
Maybe
Okay,
that's
thank you very much. Yeah, sorry.
Sorry, just a related question is, why do you think there is a kind of big shift from the approach used in basically describing the UK position statement and to like ratio-based approach? Because there must be a reason, right? So just because I'm thinking about forensic authorship analysis, in which the authorship like ratio framework is not as as not really popular as other approaches, but I want to kind of cause a bit of a same kind of a shift, but I'm kind of failing to do it, so that's why.
So no, I might have to think about that one. I mean, it's. I think, in fairness, I think Erica's talk last year talked quite nicely, didn't it, about was it last year, or the year before now, the first one of these roundtables? The development of and the change, as it's gone through. But I think just see it as part of the development of the field, really, and yeah, just in the same way that I suppose when I don't know, in the very early stages, you might have kind of more categorical statements of opinions, and there was a move away from that, to something which reflects more possibilities. So just see it as part of the development. And I said, to keep in mind, going back to what I said in my talk, I think it's just important that we're constantly thinking about how to make our evidence appropriate and also understandable, and if that's the best framework in which to do it, then that's the best framework in which to do it.
I think if I'm able, one of the reasons why, I mean, these are practical reasons to answer or give a possible explanation for Shinichi's point that the movement towards the likelihood ratio framework seems to be slow. Maybe two things in authorship analysis anyway. One is how long the publication process takes in most linguistics, at least. And secondly, and this was a question that I had both when I listened to Sheila's and to James's talk, is that, and I know that there are reasons about confidentiality and all that sort of stuff, but there's very rarely do we read any, in a forensic context anyway, any case reports where these methods had been successfully applied. I mean, the International Journal of Speech, Language and the Law, for instance, says that it also carries reports on legal cases. And I don't know when the last time I read a forensic authorship analysis legal case in that primary journal for the field. So I think if there was and I understand that there's reasons that you can't publish certain things for privacy and confidentiality, I get that, but there must be some way in which these methods that had been applied and had been successful or unsuccessful, however that's measured in the legal system, could be critiqued, could be replicated, could be validated, but there's just none of that. And I don't know whether that was a feeling that people certainly, and I mean this in the linguistic context, less so in some of the computational computer science fields and things like that, but certainly in forensic linguistics there seems to be a lack of that sort of possibility. I don't know if that's something anyone else has noticed or agrees with or disagrees with.
I, for one, completely agree. Yeah, I think there should be more publications about case reports in our journals. Yeah, definitely. Right. So for the audience, we are, of course, we give priority to our panelists. Oh, we have a question. I think we have raised hand. Jeremy Robson, if we can allow you to talk.
Yeah, I just wanted to pick up on that last point of David's about case reporting, because from a legal point of view, cases are only going to be reported if something's gone wrong, and they've gone to the Court of Appeal. So that's going to be, if you're wanting sort of documentation of successful practice in the court, that's going to be, I think, largely reliant on practitioners writing that up. So, for example, Francis Nolan wrote up his work on voice parades, and that's a case that wouldn't come to the attention of the legal community because it was a case where in fact the defendant pleaded guilty. So I think perhaps that's in part down to practitioners needing to be a bit more open and responsible for getting that information out there.
Yeah, thanks, Jeremy. Yeah, the Francis Nolan paper is a good example of that, isn't it? But yeah, like you say, that wouldn't have raised any. The legal practitioners wouldn't have paid much attention to that because he pleaded guilty. So yeah, I don't know. I suppose I hadn't actually thought of the practitioner side of things. I was just thinking that forensic experts could publish some of their methods in it, even if it was some steps had been taken to anonymize particularly sensitive stuff, and the details of the case didn't have to be particularly identifiable. But yeah, thanks, Jeremy, for that. Cheers.
Okay, we have a few more minutes. I have a few controversial items for debate. Okay, so that mostly stem from Shayla's talk, actually, and especially putting it in contrast with Shunichi's talk. And well, for sure, we'll get to that debate in the afternoon. But for now, I was wondering if the panelists could say anything about, which also reflects in a certain way what was being discussed just a few minutes ago. How much do they share the understanding that likelihood ratios for linguistic data, so speech and text, is actually nearly measuring the impossible, as Shayla said in her talk. So to what extent it's impossible, as opposed to just, it's possible, but we need to do more research on it.
Sorry, can I answer to kind of give my personal kind of opinion?
Of course, yes.
It's a kind of question relevant to all kind of approaches used in forensic authorship analysis. It's not really about approach, I would say, because yes, you know what I mean? So, for example, like ratio framework doesn't fix the already existing problem in authorship analysis type of stuff, you know what I mean? So it's just if that people talk about population data, well, it's a problem of authorship analysis in general. It's not a really just already existing problem before authorship, like ratio framework. So we just need to continue to work on those things. That is my understanding.
Right. Yeah. It's a very good point. At the end of the day, even if other methods are used, similar problems arise. So then at that point, why not just focus on likelihood ratio? that's I think it's something that we can. It's definitely food for thought. And I don't know if Maciej wants to contribute to that. I mean, so Maciej, we will hear from you later on in the day. But your expertise in several computational methods could be valuable here. So what do you think about the likelihood ratio?
Yeah, what can I say? That's a promising way to go. And generally speaking, the Bayesian approach rather than just frequentist way of thinking, this is the way to go for sure. But in most of the methods we've been using, we're still sort of not ready to switch to these ratios. As we've seen in Shunichi's presentation in the morning, we're still very much attached to this distance-based methodology, which is fairly how to say it, fairly straightforward. We sort of understand what is happening there, right? So there is a step to be done by all of us to switch this statistics heavy methodology, and that's what I can say, right? So sooner or later we'll be there, hopefully.
We have a comment in the question and answer. We actually have two. One from Isabel Piconel, who commented on top. I can't recall exactly at what point this came in, but it's relevant at all times. Probably, Andrea, in relation to your "Are we trying to measure the impossible?" And it just says, "and dealing with short texts," which of course makes everything much more difficult. And again, like Shinichi said, that's a problem with authorship analysis generally, pre-existing likelihood ratios. Tina has a comment: likelihoods do not have to be measured, they can be estimated too. The point is to consider the chance of finding what you observe in the data under both hypotheses. So that's a useful addition there, I think, to that.
I would agree with that.
I mean, I don't know, Andrea, if you have, we've got 3 minutes now before lunch. And I know we've got other pockets of space where we can have these discussions as well, because I've got a couple of things written down which I'm happy to keep until later to see what happens after the other talks. But I don't know if, Andrea, you had some more points?
Yeah, actually, to follow up this last question. So if I understood Shayla's correctly, and we will only know in the afternoon, I suppose. So what Shayla is saying from her experience of working on several authorship cases is that even if it's not measured, even if the likelihood ratio is not measured, it's impossible to even to do this comparison, right? So between what would be expected normally, because we just don't have data for that. I think that's the argument, right? But then I mean, that's what I understood. So we'll only know when Shayla is part of the panel in the afternoon. So I think that's one of the things that which should probably understand as a field. So to what extent, what are the questions that we can answer? We just need more data. And what are those questions that maybe we cannot answer at all? And then in that case, what do we do about that?
I had a similar point arising from Shayla's talk as well, which I hope when she comes this afternoon, we might be able to have a little bit of a duplication as to what happened at the first round table, which was a robust discussion about this idea of explainability to lay people, because we've already had quite contrasting opinions about that, and that's something that I think about a lot, because I think, you know, Shayla said we need to be, and so did James, you know, we need to be able to explain these to legal decision makers, juries, judges, or whatever. And you know, Shinichi and similar Stamatatos in the previous roundtable said it doesn't matter, you know, we aren't obliged to explain our methods to lay people any more than DNA forensic experts would be. So I'd be interested. I'm just going to leave that there before lunchtime and maybe pick it up later on, because this is often, when you have this sort of authorship analysis, this distinction and discussion between stylistic approaches on the one hand and stylometric on the other. Stylisticians, who I would probably put myself in that camp, often say one of the disadvantages of stylometry is that it's not explainable. But if you remove that and say, well, it's not our responsibility, then where else are stylisticians going to attach their flag? So that was my only point on that. Now we have Maciej Eder, the director, Dr. Maciej Eder, the director of the Institute of Polish Language at the Polish Academy of Sciences, and an associate professor at the Pedagogical University of Krakow in Poland. With a background in early modern Polish and Latin literature, Dr. Eder now finds himself working at the intersection, this is taken from his website, between literature, quantitative linguistics, and computational methodology, particularly machine learning techniques. Maciej has published widely on computational stylistics or stylometry in answering questions about authorship, and he also leads the team that develops the Stylo R package as well. Personally, I remember fondly when I was working on my PhD and Matthew published his 2015, it was a preprint then in Digital Scholarship in the Humanities called Does Size Matter? Authorship Attribution, Small Samples and Big Problem, and that was very timely and very useful for me, so I just want to take this opportunity to say a personal thank you, which remains a very important paper. But enough of that from me. We're very delighted to be able to have Matthew here today, and over to you.
Oh, thanks so much. Thank you for having me, and thanks for this introduction. I feel really honored to be here today and to build actually upon this very paper you've mentioned, because when I was suggesting the title of the presentation, reliability issues in authorship attribution, and then I started putting all the stuff into my slides, then I realized that, well, issues in Prolog might not work out well, so I will focus on just one issue, this one being the text size or sample size problem. Also because this text size problem has been mentioned today several times, so it might be quite timely to build on top of those things. So let me start sharing the screen. I hope you can see my slides.
Yes, all good, thank you.
Okay, thank you so much. So as said, I will be focusing on just one big issue in stylometry, which is, how much data do we need? This question has been asked and sort of answered several times. It can be broken down into two sub-questions. First of them being, well, what is this size? What is this critical point? What is the sample size, the minimal sample size we can rely our inference from? And the second sub-question being, well, how to deal with the samples that are too short to be reliable. So how to deal with uncertainty. And these two questions cannot be discussed separately. So we'll also sort of focus on the first one, but with some hopes to at least shed some light on the second one. So to give some introduction to the problem of the short sample, maybe not to the problem of the short sample, because the problem itself is quite simple. The question is, well, not the question, but the problem is that if we have no data, well, garbage in, gospel out does not work, right? It's not the way to go. So we can certainly assume that there is some amount of data that gives you no signal, no fingerprint, that there is nothing, right? And if you've got an abundance of data, you might tweak the methodology to get the better accuracy or performance or whatever you want, right? But there is certainly, we can make a very simple thought experiment, and we can assume that there is certainly a given amount of data you have to have in order to do some research. And now in this paper you've mentioned, in this 2015 paper, I was trying to tackle this problem experimentally. I designed an experiment, a controlled authorship attribution experiment. So that was the setup in which I knew the answer. So that's an ideal setup to do benchmarks, right? To do some machine learning benchmarks. So I know what the answer is supposed to be, and I make the computer guess, and the computer tries to guess, and then I count the correct guesses and assess the performance, right? But the idea was to use the same corpus in all those iterations. Unlike other approaches in which some scholars were comparing the behavior of the classifiers as applied to, say, short emails, and then to long essays, and then to very, very long novels. I wanted to stay on just one corpus for all the time. So rather than doing it in three or more different distinct or discrete experiments, I wanted to make one iterative experiment based on just one corpus, with some downsides of this approach as well. So these multiple iterations involved excerpting longer and longer samples from this very same corpus and doing independent tests for attribution, for classification. And the final score of the accuracy of F1, I don't remember what it was recorded, and it was the final number I was looking for. So to give you an example, that's an example. So a text from a Latin corpus, because I did it in several different languages. This is a text in Latin. So the goal was to just randomly grab a bunch of words, say 500 words for the first part of the experiment, right? 500 words for every single text in the corpus to make up a virtual corpus made of very short samples, right? And then, you know, that's how this corpus might have looked like. So in from every single text, 500 words were excerpted randomly, and then this sort of virtual corpus was subject to the further analysis. So I did it for say 500 words to record the final accuracy. Then for longer samples, so again because it was all done with the replacement, so all the words were put back and again excerpted, and again longer samples were excerpted from the same corpus, all the way to very, very long samples of 20,000 or so words, or exactly 20,000 words per sample, right? And it gave me like a vector of accuracies covering the samples from 500 words all the way to 20,000 words, right? And that's the very vector I was interested in. And after plotting such a vector, you see that we've got something we could expect to get. So a steep increase of performance followed by a plateau, a statistical saturation. And here you see this point where the saturation starts. It's not 1,000 words, it's like 7,000 words perhaps, ish, right? It was quite shocking to me to discover that we need such long samples to say something reliable about the texts we deal with. For some other languages, for example, for ancient Greek, this magical number was lower at 3,000 words ish. For Polish, it was even worse. So it depended on the language, but the final numbers were thousands rather than hundreds of words, and that was quite disappointing. And now, I still like this study, but I'm going to sort of trash it right now because what this study did not pay attention to at all was that it was trying to assess this ideal Platonic mean behavior of the corpus, as if the variation between authors was not the case. And what I liked about Lynn's presentation was the assumption that variation is not just the noise, right? So we might deal here with a very similar situation here. Of course, before I go any further, there will be probably a question from the audience that rather than fighting over fitting, I will take a U-turn and push you into the world of individuality. Well, yes, that's a trade-off. So I will be very happy to tackle this question during the discussion. So this arithmetic mean, or the mean behavior of the corpus, might be beautiful as it is, but it also assumes that every single author is identical, which might or might not be true. So this authorial signal might be stronger in some cases. I mean, I don't even want to open this door of why some signals might be stronger. But think of some authors. You open the book, any crime story by Chandler, and half a page, and you can tell it's Chandler, right? But on the other hand, you open Virginia Woolf, and for pages and pages, you're not really sure because she's so Prothean in her style, right? So there might be some authors on theoretical grounds. There might be some authors in the case of which the signal will be stronger, right? And the question is, how can we tackle that individually? Also, in the forensic context, some fingerprints are stronger, some are not. So can we tackle this individually? That's the question I wanted to ask in this study. But before we go there, I suggest that we conduct a very simple thought experiment. We've got two attribution scenarios, made up authorship attribution scenarios. In the first, the question is, can we tell apart Chaucer and Hemingway and say who wrote Canterbury Tales? Whereas in the second one, that's going to be much more difficult. We've got, say, Macbeth, and the question is, was it Kate or Shakespeare to have written that, right? In the first example, you just need 100 words to tell apart those two authors. In the second case, well, maybe 1,000 words or 10,000 words is still not enough. I don't know what is the number here. We're just doing a thought experiment, right? Just to realize that the strength of the signal might depend on the setup of the corpus. If I put into my corpus very similar author, whatever the similarity means, right? If I put similar authors, then the signal might be blurry. When I put very distinct authors, the signal might be strong. Yet another thought experiment in which the scenario number one, we've got just two authors and we have to tell who is the author of the Dubliners, say, is it James Joyce or is it Virginia Woolf, right? So we've got one of two, a binary problem. So the baseline is 50%, we just toss a coin and we sort of have a chance to get it right. Whereas in the second scenario, it's not so easy if you haven't read The Heart of Darkness to tell who was the author of that, right? So this second very simple thought experiment teaches us that also the number of classes might be an important factor here. It's quite obvious, right? But it's really useful to realize it before we start thinking of setting up an experiment. So in this new, not so new because I did it a couple of years ago, I just have no time to publish it. This new approach of mine suggests that we might assess the problem of the sample size individually for each single text in our corpus. So the assumption being here that the minimal sample size is not the holy grail, right? We are not looking for the number, but instead we might look for this number attached to particular authors or even particular texts by particular authors. Also think of different genres. In some genres, the signal is pretty strong, right? Whereas in some other genres, it might be blurry. So in poetry, it's relatively simple to extract the signal. In forensic context, it might not be so simple. So there are other different factors to be kept in mind. Not only the authorship, but also particular text by particular authors might be assessed individually. So the experiment I suggest, or I performed and designed and conducted is as follows. So I've taken a benchmark corpus of English, which we can grab from our webpage, which is 100 novels covering late 19th and early 20th century, 33 authors, 1/3 being female authors, exactly 3 novels per author, and one novel here is presumably anonymous. We know who the author was, but it was one of the authors collected within this corpus, but still. So I just disregarded this sticking out novel and focused on 99 novels by 33 authors. And I also have taken a similar benchmark corpus of Polish. You can also grab it from the website. And this is going to be a commercial break because those two corpora have become a part of the LTEC corpus comprising of 1,200, at least 1,200 we are getting to increase those numbers, 1,200 novels in at least 12 different languages. As a product of the Cost Action distance reading, you might also grab this corpus from the distance reading Cost Action webpage. So with this corpus in hand, the idea is to design a supervised setup, right? So the answer is known, so the authorship is known, but in this setup, exclusively the text in question would be subject to those tortures, right? Whereas all the other texts would be kept in the training corpus, in the training set. So this is an equivalent to a leave one out cross-validation scenario. So once at a time, one single text is being pulled out of the corpus, of the training corpus, and being stress tested against the training corpus, right? One at a time. And then in each of the iterations, each text would be picked out. And then in, say, 100 iterations, in 100 times, so that the counting is easier, n number of randomly excerpted words would be picked at random, right? So in 100 times, 100 samples would be drawn randomly, comprising of say 500 and 600 and 700 and all the way to some larger amounts of texts, larger amounts of words individually, right? And in each of those 100 samples, the attribution test against the training corpus would be recorded. So the final score would be from 0 to 100, right? 100 being a perfect guessing. So in 100 out of 100 times, the sample would be guessed correctly, whereas 0 would be well, misclassification. Total epic failure, right? And this procedure would be repeated iteratively over the corpus and over the text and over the sample. So quite a lot of replication would be involved here. And now to compare it against different classifiers, because that's an issue. Again, when I was planning this speech, I was also thinking of saying a few words about different methods and the issues with different methods giving slightly different results, but these different results are not necessarily consistent. So just to take this into account, I did this experiment, I replicated, I replied this experiment with different classifiers, starting with the delta and its variance. So the classic delta, my own modification of delta, which is a fairly simple one, and then the cosine delta, also mentioned today many times, and the so-called min-max distance, which takes ages to compute, but it's considered to be okay, not as good as some people think it is, but still. And then support vector machine and US shrunken centroids, so that the range of classifiers is rich enough. And now, one of the issues in stalometry is that we don't really know what is the perfect number of features, what is the perfect number of, say, most frequent words. If we rely on most frequent words, there are different ways of working it around, but still we don't really know what is the perfect number. So I did it iteratively for 100, 200, all the way to 1,000 most frequent words, so that all the possible combination of the vector of most frequent words is covered. Now, I didn't extend this study to other features, such as word bigrams or letter trigrams or anything like that. But that's extendable very easily to other features if you feel doing so. So if now we discuss the results individually, rather than for the entire from the entire corpus. So let's start with, say, Joseph Conrad's The Almayer's Folly, which, as you can see, all the particular dots or the particular points are those hits of the 100 samples being attributed 100 times, right? For different most frequent word numbers, right? I will replace it with some trend lines instead. But whenever I show the trend lines, please read the dots that are in the background. So as you can see, it's not 5,000 words anymore. It's like 2,000 words, and we're there, and even less. I would say 1,500 words, and the Almayer's Folly by Conrad is there. That's a very good news indeed, right? And when we move on to assess some other authors as well, Nostromo by Conrad, very similar picture, again, less than 2,000 words, which is a fantastic news, right? So this, I'm very happy to just have trashed my previous study that 5,000 words or you won't have any reliable results. Well, it depends. You can find some other solutions and workarounds. The Rover by Conrad, similar situation, but as you can very easily imagine, I'm showing the results starting from the nicest ones to some more problematic ones, right? So here it begins. In some cases, when you slice those particular texts into samples of longer and shorter lengths, then you see that, for example, here, if you take 100 most frequent words as your features, the performance is not perfect, right? It's far from being perfect. When you take 1,000 words as your feature, then yes, you're there, that's fine. The problem being that if you do it for other corpora, for example, for Latin, you might see a reversed picture. In the case of which 100 most frequent words works perfectly well, and a very long vector of 1,000 words doesn't really work. So please be prepared of seeing some troubles, of seeing some backsides of this setup as well. So the good news is that it's like 60–70% of the instances are very similar to this previous picture, or even to that picture, right? So we've got a very nice clear-cut picture in which like 2,000 words is the answer, which is good. For novels, for English novels of the turn of the 19th and the beginning of the 20th century, of course, I should add this disclaimer at every single sentence. So this pattern is not only is this pattern frequent, but also sometimes it's really clear-cut. So Edward Lytton, my novel, very nice, 1,500 words, and you've got the guy, right? And you can pinpoint the guy. Thackeray, The History of Pendennis, also not a bad one, right? Again, this 100 most frequent words feature vector is sort of underperforming, but on average, we can see that the signal is there, right? When we move to Thackeray, The Virginians, again, a very nicely clear-cut pattern, which is good. And Trollope, ALS Angel, even more so, right? So it really depends, and we have just proven this assumption that in some cases the signal is very strong, whereas in some cases, as you will see in a minute, the signal is not strong at all. Trollope Phineas Finn, same picture, right? As in ALS Angel, and that's the Phineas Finn novel, same story, right? Very short sample, and you can pinpoint the person. And there is one example, William Morris, in the case of whom you take just 100 words. You take one paragraph of this person. I haven't read them, but the signal is super strong, whatever you do, right? So that's a very good news. But at the same time, this is an outlier. So as you can easily guess, I will also show you some outliers on this other side of the spectrum. So that's William Morris with totally strong signal. I don't know, what he does, because 100 most frequent words. What can you do here, right? But the person manages it to show his fingerprint even when you grab one paragraph of him. Well, but that's around 70% of the text in this corpus. Same about this Polish corpus. Then these numbers are not identical, but fairly similar. However, there are some other examples, because you might ask the question, and that's going to be a very valid one. If this Platonic beauty of the mean was showing me 5,000 words being the minimal sample size, so why am I showing you this beautifully short sample examples? Well, there is also this other guys that distort the picture, right? So The Odd Women by George Gissing, it reaches its plateau at 4,000 words for sure, but for 100 most frequent words, that the gray line, well, the more words you take, the more visible the signal is, and we don't know how much of the words, of the running words from this novel we would need to have, right, to finally see the signal. We don't know that. Well, as Elizabeth Gaskell and her Ruth, right? Similar story, 4,000 or 5,000 words, but again, at this time, this long vectors of features, 750 features. This is the worst performer here. And the not so good news is that there is no systematic picture. Sometimes those long vectors seem to work better. Sometimes this is the short vectors that seem to work better. To which extent this is overfitting, to which extent this is something else, we don't know. Yeah, and here's where the bad news commences. Roderick Hudson by Henry James. As you can see, it's very poorly recognized by the system. Of course, if your system on average, if you do authorship attribution benchmark study and you say that you can achieve 80% accuracy, right, 0.08 accuracy, then you might ask a question, so where's the remaining 20%? That's one of those, right? That's one of the texts that does not fit to the picture, right? So no matter how long the vector space, how long the sample size you take, you're still not there. Is still not visible. Of course, if you take 300 words or 200 words and extend your sample, it's starting being visible, but still you never reach it, right? Even worse for some other texts, for example, Trollope the Warden, which depending on what vector of features you pick, it might be either very unsatisfactory, right? 100, 200, 300 most frequent words, nothing, the signal is not there. And 1,000 or 750 most frequent words, the signal is already there. When you take 1,500 or 2,000 words, the signal is there, right? So this is one of the questions I have no answer to, why this vector of words is sort of unpredictable. But even if it is unpredictable, you can sort of extrapolate from those who work, right? Here you see that the signal starts being visible at the length of 2,000 words in a sample, which is like 4 or 5 pages of running text, which is a great news. Yeah, that's the light that failed by Kipling, which is even worse. So, right. And again, what is the valid one? I would say the 1,000 words, because that's the clear-cut shape that we are already used to. But still, you can also argue that we don't know, right? That the signal is problematic here. So apart from finding this very moment when the sample size does not matter anymore, we can also use this approach to verify if the signal is there at all, right? As in this very example. came by Kipling. It's not recognized across the board. Whatever you do, or whatever kind of sample you take, whatever kind of classifier you take, whatever kind of most frequent word vector you take, the signal is simply not there. And to show the final example in this part of my presentation, Virginia Woolf. She is a very good writer in terms of she can mimic someone else's style, or she can change her own style from one book to another. So that's The Years by Virginia Woolf. You know, this kind of picture we already used, right? That depending on the vector of most frequent words, we either have hair or not. That's The Lighthouse by Virginia Woolf. Again, something totally unpredictable happens when you take 100 most frequent words, but for all the other vectors of words, you can pinpoint her for sure, but you need to get some more textual data to deal with. But when you take Night and Day by Virginia Woolf, well, it sort of starts to recognize her, but then it collapses. And again, if you do unsupervised analysis, and if you try to do some hierarchical dendrograms of this period of of English literature, Virginia Woolf is spread across the board. She is really changing her style from one book to another, and we've got a proof here in this picture as well. So we've just arrived to some provisional conclusions, because I also want to open new front in a couple of minutes, but still revolving around the sample size. So far, what we know is that it quite a lot of cases, very, very short samples of, well, maybe more than 1,000, but surely below 2,000 words should be enough to show the signal. Well, but some other cases, some other texts require more, the signal is weaker and it requires longer samples. And something I didn't expect to get is that those longer vectors of most frequent words work also in the case of very, very short samples. So the situation when you've got lots of zeros, because if you've got a sample size of 1,000 words, then you will never fill up the 1,000 most frequent words a vector with, with non-zero numbers, right? So those zeros seem to play some role here as well. So as I said, I also wanted to open a new front, meaning that in my setup so far, the situation was that the computer had a fairly difficult a task of distinguishing or of guessing the correct answer out of 33 possible classes, right? What if I tweak the number of classes? So that's the example that you've seen already, the amount of property when I contrast it or compare it against the 33 classes. And that's the same text when I compare it just to one other class. I don't remember what it was, Dickens or something like that, right? So it also is a factor to remember of, right? The composition of the corpus. If you do the needle in the haystack kind of scenario, right? You've got 5,000 authors and make the computer pick the correct answer. It's way more difficult than when you deal with the binary classification, right? So this is something we should be also aware of. Galsworthy over the river against 33 classes, and the perfect guessing, not perfect, but much better guessing when we've got only 2 classes. Same about Vernon Lee, the Countess of Albany, against 33 classes, no recognition at all. And well, yes, perfect recognition when there are only 2 classes in the picture. In this comparison corpus. So this is also a factor that is not universal, that should be taken into consideration. Of course, we know it on theoretical grounds, we know it, but that's how you can also experimentally prove that, well, this matters. Well, yet another Vernon Lee, which is badly recognized and quite nicely recognized when you take two classes. And this is a pattern. This is the universal pattern. When the number of classes decreases, then the recognition of the text decreases or increases. And yet another digression, I think an important one, and this is the assumption, a tacit assumption that I've been doing so far, that those outcomes are independent on the classifier, that these are quite universal no matter which classifier I use. Well, the problem is these are not. That's the classic, because I've been showing you the classic delta outcomes so far. So that's George Eliot, Daniel de Ronda, using the classic delta approach. We can recognize the familiar pattern, of course. And that's the same text, the same setup, the same everything else, except that the classifier has been replaced by the cosine delta, right? As you can see, it's sort of finding its way until, you know, the very, very long samples are being found, or are being taken into play. So that might be a problem. And to tackle this problem, I did sort of a in the big introductory part to my presentation, I said I won't be using the Platonic means, but that's, you know, I just did the average behavior across the board for classic delta versus the cosine delta. And as you can see, this cosine delta, which is considered to be a better classifier than the classic delta, on average is more sensitive to data sparseness, right? So it seems that we've got a trade-off here. The better classifier you've got, the more data you have to feed it with, right? That there is no free lunches here. And when I did sort of a large-scale comparison between different classifiers, it turns out that those classifiers that are considered to be very, very strong solutions, such as support vector machines or cosine delta, well, these require more words in a sample to finally show their potential. So no free lunches, I'm afraid, right? Those classifiers that are not so good on average, like nearest Shanklin centroids, these are fine with very, very short samples on average. And this applies both to very short and very long vectors of most frequent words, right? So this is also something I didn't expect to get, but after all, it's not that unexpectable. So what we've learned from those two digressions, and then, you know, I will just move to the final section, is that a text that fails in, say, a scenario involving 33 classes might be working very well for just for a two-class scenario, right? Also, we find that the classifiers are also playing some role here in this equation, which I hope wouldn't be the case, but unfortunately no. And quite counterintuitively, or maybe not that counterintuitively, those good those well-performing classifiers seem to work better with longer samples. I was just hoping to have this cosine delta to save the world finally, but no. There are some other issues with this classifier. If it works well with some setups, it doesn't work in the setups when the data sparsity is the case. And now I have just arrived to this final part of my presentation. I just need a couple of minutes to tackle that, but this is the most important one, because so far I've been talking on a situation where I knew the answer, right? So it's really, really simple to test if the computer can guess Dickens or Thackeray or whoever else. But what if I deal with a real case authorship attribution scenario and I don't know the real answer, right? That might be a big issue indeed. So instead, or maybe not instead, but apart from using this measure that you've seen already, I suggest that we might focus using the very same setup. But this time, when we have no grand truth, what about focusing on just an index of how hesitant or how confident the classifier is. So what I suggest to use here is a Simpson diversity index, which tells you to how many different classes a given sample was assigned. If a given sample was consistently assigned to just one and the same class, right? I don't know if this class is right or wrong, but I know that it has consistently been assigned to that one class. It tells me something about the probability of this given text belonging to that class, right? So you might think that this is still the same picture. No, it is not. This time, this is the diversity index. So this time, the very same setup has been linked to a different measure, final measure. And this time, this is the measure that tells you how dispersed was the final answer of the classifier. And as you can see, if you take like 1,500 or 2,000 words, the classifier is fairly consistent, right? Whatever you do, it's consistent. And this gives you some idea of, that we might be dealing here with the final author, final suggestion of the classifier. That's an example of the text that you've seen previously, which was blurry, and it's still blurry, right? When you use this diversity index. But this time, my assumption is that I have nothing to compare it to, right? I just have a corpus to compare my unknown sample against. Vernondi, Penelope, Brenling, which was also routinely misclassified. And as you can see, the diversity index is also flagging it as a suspicious text, right? It's really difficult, the classifier says, to link it to any final text. Night and day, the text you've seen, again here, the diversity index says it's fishy, it's suspicious. Okay. I've got 2 minutes left, so this is just enough to draw some conclusions. So as you could see, in most cases, those 2,000 words tend to be the decisive number, right? So forget about 5,000 words. Forget about this pessimistic, negativistic ideas of having 5,000 or 7,000 words. 2,000 words, and you're fine in most cases. And if you limit the number of classes, then this number can be even lowered. I mean, as we could see that, right? That even a very, very short sample, when the number of classes is not big, makes it possible to perform a successful attribution. But some other texts require much more samples, and even then, you sometimes are not able to link them to their respective authors, and I'm sorry, that's what it is, right? And finally, this diversity measure, there's plenty of those diversity measures. I just suggested using the Simpson index, which is the simplest one, might improve the real life classification when you don't know the grand truth, right? When you've got your sample, you can test it against the corpus, and you can see how consistent the outcome of the classifier is. And now, not only that, but I like this method also as a diagnostic tool. I mean, you can just grab your text in question and do this torturing, you can torture the data set if you have on your desk until this data confesses or something like that, right? So you do this atrocious things to those very, very short samples, and you see how stable your sample is, how, what can you squeeze out of it, how much of the signal you can extract when you torture the sample by trimming the sample size, for example, right? So you can address many different questions, going even beyond forensic context. For example, why some authors are so successful in changing their style? Is it connected with, well, with what? That's a question that you can try to assess using this kind of a diagnostic tool. Okay, that's all for today. Thank you very much for listening, and I will be very happy to address some questions in the discussion part. Thank you.
Right, great. Thank you very much, Maciej. And so David send his apologies. He had to leave, unfortunately. So I'll chair the rest of the session, and we'll have a few questions now, hopefully for Maciej to begin with, and then I'll bring everybody else from the panel, and we can have more general discussions around all of the themes that emerged during all of these fascinating talks. So while we wait for questions that are specifically to Maciej, well, I have a few. So if you don't mind, I can start. First, a quick clarification. So whenever you talked about the limit, right? So 2000, the old 5000 and 2000, we are talking about the size of the text to attribute. Is that correct? Now, what about the size of the training data or the known data set?
Yeah. That's a question. Actually, Jack is here with us. He did a nice study on that. When you've got plenty of training data, then you can limit your sample size, your actual sample size radically, and you still can see the signal. So that's yet another question I didn't really tackle in my in my study, and this is the proportion of the training versus the test data. Plus, in real life attribution setups, you cannot really control the size of your training set, because you've got what you've got. You've got like 30 or 40 something texts by Shakespeare, and only 3 or 5 by Kidd, something by Johnson, right? It's very, very difficult to control for the size when you deal with a real case attribution study, right? But in this laboratory conditions, you can of course extend it as much as you wish if you have enough training data. Or once I did a study, not a real one, but that was just a study to test the methodology, to distinguish between 2 French 13th century authors, Jean de Man and Guillaume de Lory. The problem being that in the case of the second of the authors, we've got plenty of training data, and the first one was just very, very sparse. 1 or 2 poems, nothing really substantial, right? And the question of this imbalance between classes, that's the real case problem, as it turns out. So I didn't answer your question, I know that, but if in laboratory conditions, this is the question to tackle: how much you can restrict your training data to still see the signal. I totally agree that this is the issue.
Right. We have a couple of questions, but just to clarify again. So when you, if I understood correctly, when you apply delta over there, that was nearest neighbor, right? So each text, so you calculated the distance between each text with each other. And then if the attribution was successful, if one of the known author's text was the first one in the ranking as the most similar.
Right. Yeah.
So essentially, the training data is the size
bunch of individual points. Yeah.
Okay. All right.
Which is not the case in support vector machines and in nearest ranking centroids that try to generalize those different points in the space into one class. So I did, I compared those deltas, different deltas, and Shanken centroids and support vector machines to see that if the differences, if there are any between those classifiers. Well, they are, but I don't know what is responsible for those differences.
Okay, thank you. Okay, so we have Christopher Credence. Whether it's a long question. Okay, I'll read. So really interesting, Maciej, thank you. How do you know you're actually matching individual styles rather than topic, genre, and so on? Conrad, for example, is known for his generally gloomy outlook on the human condition. So isn't what you're capturing there essentially a quality of gloominess? Do you look under the bonnet in your research? Are you interested in issues of validity?
Yeah, that's a great question, but there is no no serious answer to that, because yes, you deal not only with one signal, but also with other signals those authors bring with them, right? So not only is this the authorial signal that they bring into the table, but also the genre. And the question is, if you pick a genre, if you want to start writing epic poetry and you change your style, is it because the genre requires you to do so? Perhaps partly yes. And sometimes, you know, some people think that they are not good in writing epic poetry, maybe because their individual style is also not very much fitting to that. So genre, the choice of genre, the time span when you're active. I mean, Shakespeare being different from say Dickens, which is obvious, is not only different because he's Shakespeare, not Dickens, but also this is the early 17th and mid 19th century kind of thing, right? So there is more and more signals involved here. The level of education, what else? There's you know, some dementia issues if you suffer from them, right? Some psychological issues might be also a part of the game. So it's really difficult to tell apart the gloominess and Joseph Conrad-ness, right? So I'm sorry that I don't have any clear-cut answer, but they can't be any, I guess. Of course, you can control the experiment as much as possible. So you can make your students write an essay on the same topic, the students being at the same level of education and so on, right? So you can do this laboratory experiments, but in the real case, you cannot simply extract this, or not extract, but get rid of this gloominess and focus on just Joseph Conrad. Maybe if you do just your analysis on very most frequent words, something like that, so that to avoid the content or topic words. I hope I answered that.
Yeah, so Christoph is thanking you, and he adds that incidentally, your study confirms the kinds of results we had with hundreds of thousands of authors. Some individuals show much more individuality in language use than others, whereas others conform more, and they used discussion forums. Okay, thank you, Christoph. And we have Jack Grave that would like to ask a question orally, so I'll give him permission to talk. Jack,
can you hear me?
Yes.
Oh, yes.
Thank you. Thanks for a great talk. I thought it was you know, really nice to see kind of the empirical evidence, how like the specific authors and the number of authors matters. I think that's probably something that like forensic linguists like doing forensic stylistics tend to believe already, but I think it's something that isn't always appreciated in stylometry, or maybe never, and nice, like I said, to see it. I guess I'm just wondering, like, you know, so it's nice to see like classifier controlled and number of authors controlled, and even like who the authors are, and like Andrea was mentioning amount of training data, but I just wonder, like, there's a bunch of other kind of factors that went uncontrolled. I guess most notably like the feature type. So there was like a sort of an assumption made that, you know, that the most frequent words, I'm assuming these are like one grams, are the best feature, and that, you know, and that we can just test different kind of ranges of numbers of frequent words, and that gives us like a good test of what's like doable. But, you know, I wonder about that assumption, and in particular, like, you know, like if well, that in particular, the set of words would change quite a bit across different author groupings. So I just wonder about that, like basically, like, you know, instead of just, and I guess more specifically, like instead of just looking at the top 50 most common words, why not look at like the top 50 best words? Like, I just think we could get each of those results better by playing around with the feature set. So I just wonder a bit about that, and just kind of like wonder if like with stylometry and or with forensic stylistics in general, kind of the view is that you really need to get a different feature set each time you do it. So maybe that's sort of another angle where we can get those kind of average numbers down and get better and better. Thank you.
Yeah, thank you very much for this question, and we meet finally, which I'm very grateful for the opportunity to. Yeah. So yeah, that's a great question, and thank you for that. And well, yeah, to some extent, well, the good question being to which extent different features are collinear, right? So the most frequent words, to which extent they are collinear with, so say, part of speech tags or part of speech tag n-grams, and to which extent they are showing different parts of the language, right? To which extent we can have an insight to different areas of the language. I hope the latter is true, so it makes sense to explore different features. But I have no answer to the question whether if you switch from most frequent words to some other features, syntactic features, for example, if the picture is going to be similar or not. What I can say for sure is that when you stay on the most frequent words as features and change the research question from authorship attribution to, say, genre recognition, then this number of words in a sample might differ, because also not only the authorial signal might differ between different authors, but also this genre signal is requires longer or shorter, rather longer than shorter samples. So I cannot answer the question to which extent the switch to other features will help it, or maybe the other way around. I don't know, but yeah, thanks for the suggestion. It should have been done also with other features as well.
Great, thank you, Jack. We have a question from Anna Wegman. Very interesting talk, thank you. My question, you used a random sampling with replacement for generating your samples. Did you explore what changes when you take connected sample, for example, whole paragraphs?
Okay, I didn't in this study, but in this previous one, in this first one, I was criticizing that much today. Yes, I did a comparison between the samples drawn randomly throughout the text versus passages, longer and longer passages. And counterintuitively, it turns out that when you grab passages, so paragraphs or half a page long samples, something like that, the required sample size is even worse. It's even longer. So it is better, after all, to draw the samples randomly throughout the text to get a better understanding for the classifier what the class is about, right? So this previous comparison shows that random sampling is a better solution here. Even, of course, this is the bag of words assumption in the wild. That's that's archetypical bag of words assumption, right? When you grab randomly from the entire text a sample of those words. But it seems that it works quite well.
Okay, right. Can I actually maybe follow up and ask, have you ever done a test, a similar test, but using, as some authors would say, a profile-based approach, where instead of having, like, for example, for Delta, instead of having separate tags, you join all of them together? And does that change anything?
Well, frankly, I don't know. But that's a great idea to test it out. Okay,
right. So if there are no other questions, strictly speaking, for Maciej, then I'll just move all of the panelists together using a gallery view. And I'll just propose a few things, a few ideas, kind of combining all the themes together. Sheila, are you actually here? Can you hear me? I know that she had a busy day today. Okay, so anyway, so going back to, so one of the things that I wanted to ask the panel is, going back again to the measuring the impossible, and connecting it actually with Maciej's talk and his results. So we have all of this variation, right? And so we see that not all authors would manifest individuality in the same way. But is that necessarily a problem for linguistic identification? And this applies to forensic speech science as well, right? So actually, that's an interesting question for James too, whether the same degree of variation of individuality applies to speech. I would think so. But in any case, to what extent for forensic application do we think that this is actually a problem or not? Because in a way, we could also say that for forensic applications, as long as we know that it's impossible, that's fine too. So if we can define that, okay, in that range, we cannot answer that question. We know that we cannot answer that question. That's probably already useful for forensic applications. So yeah, I would like to hear your thoughts about this. So in other words, potentially knowing that we cannot do something is actually also useful information. And James, if actually we'd like to hear from you whether this kind of difference in individuality signal is also found in speech.
Yeah, I mean, from my point of view, in speech, you've got two types of variation, right? So you've got within speaker variation and you've got between speaker variation. And I don't think that variation is something that stops you being able to do, well, it depends. Because obviously if you've got, because I'm trying to think of an example, so you could have an example in speech where you get two samples, and let's say that, for example, you've got a really short question sample and it just contains, I don't know, somebody shouting or screaming down a phone, and you've been asked to compare that to a very kind of a low-level mumbled police interview. Well, it could be, depending on what's in there, it could be that actually the variation that you get between the samples, you know, the shouted short nature of one and the very low-level mumbled nature of another one, cause you to say, look, I don't think these two samples are comparable. But at the same time, the more what you might call sort of natural kind of within speaker variation and between, I don't think that it stops you doing analysis. I think it's just something that we need to be aware of and understand, so that what you don't end up doing is assigning weight, evidential weight, to a difference that is either predictable or just as a result of sort of natural variation in speech, and having some knowledge and understanding of how those things work, I think certainly in speech analysis is very important. So that would be my sort of input into that area from my personal point of view and what I do. Whether that aligns with the type of things that we've been hearing about in terms of authorship analysis, I'm not sure, but that's not for me to say. I suppose that's for the rest of the panel to say something about.
Yeah, I also have a quick comment. So the text that I looked at, so I also compared like these 50 different authors, and in my findings, it was the case that the between author variation was actually larger than the within speaker variation. So knowing that also gives you some range that you can work in.
Was that the case even across genre? Because that would be really surprising. So, you know, like, so two texts from the same author but different genre are more similar than two texts from the same genre but different authors.
Well, this was not part of the results that I'm talking about was not comparing those, but within the same group of authors, speaking, so within the same group or community, so to speak. So yeah, you would have to define like some coarser grained groups of people working in a similar genre. So yeah, you would have to control for that.
Can I just add something just on to what I said before, which I didn't mention, which I should have done, which is that in forensic speech science, certainly, it also depends on which particular feature you're analysing, because you might expect some things to vary more predictably or naturally than other things. And I know that there's been some research done out of a couple of projects at York that have looked at this, certain features where you might expect greater between speaker variation than within speaker variation, or vice versa, and actually kind of unpicking that a little bit, not just on a general level, but with respect to particular parts of the analysis or particular features, whether that be, form measurements or pitch or voice quality, etc. You get the idea. So that's another level of issue that we have to deal with. It's variation across different features and different types of features, and thinking about how those things might work together. So yeah, I'd throw that into the mix as well as another slightly just to complicate things a little bit more,
Yeah, exactly. What is valid for one construction or word or a feature doesn't necessarily have the same results for the others. Yeah, I agree.
Okay. I had a few questions about Maciej's talk, but maybe I can connect them to Shunichi's talk as well. Shayla is back. Shayla, if you feel free to reappear whenever you're ready. So the distance method. So Shunichi talked about the, can I say, the superiority of feature-based method over distance-based method. I don't know if you want to put it in these words, but so you can correct me if I'm wrong. And one of the reasons for that is because feature-based methods, they include information about typicality, if I understood correct. Now, what I would like you to clarify, if possible, is why not? I mean, it's my understanding that distance-based method can also include typicality, because if typicality is defined as the support for the defense hypothesis, then you can have that information from distance-based methods too when you do different author comparisons, right? So am I missing anything here?
No, you're absolutely correct. Even score-based method, the one I particularly use is called similarity only score-based method. You can definitely include the typicality information even if you use a distance measure. That is perfectly correct. And a lot of people actually argue, not a lot of, but some people argue the important thing is the inclusion of typicality, not just a similarity. So, you can do it, score-based method, including, you can do it. It's not a problem. And actually that would be more appropriate, I would say. But just because simply just calculating similarity between two documents has been kind of a used approach for a long time, I just stick to it because it is easier to understand. The important thing is that people often say just the ratio between the similarity and the typicality.
Okay, and so now let's assuming that, say, Maciej were to replicate this study but using a likelihood ratio. Okay, right. So putting both of you together.
Looking forward to it.
Do you think, so Maciej, do you think some of these problems would be solved? Okay, solved in the sense that the likelihood ratio would give us at least a way to weight the evidence, which is really what forensic linguists need, right? So connecting to what I was saying before, I don't know answer is a valid answer as long as it's correct. So if it's true that we cannot possibly know anything about this, given the data we have, that's fine in a way forensically, because that's what we want to be able to say. So do you think that in other words, do you think that the likelihood ratio would actually help with quantifying the weight of evidence?
I think so. I hope to. I'm actually looking forward to apply it. What I'm not entirely happy about the distance-based methodology is that it's ultimately about comparing, right? It's about ranking. So what really counts is the nearest neighbor rather than the question how probable this nearest neighbor is, is in comparison to other neighbors. So this out of the context measuring the ranking of the candidates makes the distance-based approaches slightly limited. So I'm quite new to this Bayesian thinking, and I'm trying to explore it further. But I think there's quite a lot of potential by using this log likelihood ratios and other Bayesian approaches to stylometry. What I did without knowing I'm doing it, I'm doing some Bayesian statistics approach, is this replication, right? Or dense sampling from the same pool of, well, a posterior probabilities. So my approach, even if I didn't know that by the time I was doing it, is using this idea of making quite a lot of evidence out of very sparse data set, right? Just to compare it by intense replication, by intense resampling, what the likelihoods are without calling them likelihoods and without counting them likelihoods. So the step between the approach I did and what Sunichi is proposing is quite short. So there's just one tiny step to be done to verify those findings. And as said, I'm looking forward to add this one additional step to that approach.
What I'd like to actually say, do you mind if I say? Because James also mentioned about two variabilities important in speaker, French text, French speech, voice comparison, French speaker comparison. Two variabilities basically between speaker within speaker variability. Those things are very important in French authorship analysis as well. Within author, between author. Variability, that is something Lin also referred to. But all of those things related to uncertainties. Because of those variabilities, we have to assess uncertainty. The best tool we know about assessing uncertainty is probabilities. That is what I think we have to rely on. So that is kind of my basic standing point.
Yeah, Lynn, please go ahead. You're just muted.
Sorry. If there are no reactions to this point, I had another question, but first I want to ask you if there were any comments on the previous point. No? Okay, then I'll just go ahead. So I wanted to follow up on the genre question that we had earlier, because this is creating some debate, obviously, and Machi also pointed out that there's always a variety of signals we have to include. So I wanted to turn the question around and ask your opinion about what do you think, to what extent could genre also influence or be part of the fingerprint of an individual? Because there's also some interesting work by Verhagen looking at different people in HR, applicants, and then people who are not connected to the job market. And they found that people's reaction times to different words within job hunting changed, differing depending on which group they belong to. So if you're really exposed to a particular genre on a day-to-day basis, to what extent can this become part of your individual identity? So I would love to hear your opinion on
that. Well, I think personally, I think it's fascinating, and I'll just sending you a message to, can you email me the reference? But you can maybe post it in chat as well. Maciej, did you have anything to say? Please go ahead.
Well, yeah, the question, what is an author, right? Is the author just a combination of all the text they have ever written, or maybe the combination of all the possible texts they might have written in their life spans? A good one, right? Plus all those influences. If I get influenced by, say, James today, and I change my way in which I speak, is it still myself or not, right? So plus, you know, this evolution of style over time, right? Think of that. Plato, for example, the first person to be stylometrized ever because of the development of his style and the need of discussing the order of the Plato's dialogues, right? So we know that people develop. Same about Dickens, same about other people. Agatha Christie, in the case of whom dementia must have been the reason or the factor deteriorating her style. So the good question being, what is the author after all? What we could actually, that's great about stylometry. What we could prove, unlike literary theoreticians who were discussing the idea of the authorship back in the 60s, back in the 70s, and the death of author has been claimed, and so on and so on. After all, we can prove that the authorship is there. We can isolate the signal in most cases, like in 90% out of 100, we can isolate the signal. So the author is there. But the good question is it just a combination of everything? I don't know.
I suppose so, to a certain extent, it's a philosophical question, but I mean, it can also be just a psychocognitive question too, right? So, I mean, the individuality. Christoph is saying, I'm sorry, but there is no proof much, and certainly not in the 90% of the cases.
Yeah, that's right. 90% if you take a random corpus, which is a totally different thing. Yeah, I agree. You're right.
Christoph, if you want to participate and contribute verbally, just raise your hand. Okay. No, I was just saying that. All right. Okay. Permission to talk.
Thanks, Andrea. Can you hear me?
Yes.
Yeah, I just, I mean, don't get me wrong. It's all really fascinating, and there's obviously some really useful research there. But I just wonder to what extent the particular studies and the various studies based on novels, to what extent they are actually generalizable to forensic contexts. And I personally don't think they are. So the whole idea of stylomes and fingerprints and right prints, I just don't think it holds. We just don't have the evidence. I mean, stylometry is certainly helping to come up with new ideas and new avenues of research. There's, in terms of features, for example, in terms of methods and so on. But I would suggest that we just don't have the evidence. We can't go to court and say there's this fascinating research by Maciej, and he's shown that above a certain threshold, attribution rates increase significantly. Because if we say that, the linguist working on the other side is going to say, well, that's all very well, but he worked with novels, and what we've got here in this particular case is a suicide note. So do you have any information about suicide notes or threatening letters and so on? Yeah. So, I mean, when you were at Aston, Andrea, we've had these discussions before. And one solution I remember you advanced was, let's employ 1,000 authorship attribution scholars over the next 10 years and see what happens. This was your thought experiment. You may not remember this, but yeah, and you know, so using your thought experiment, if we had money to pay 1,000 authorship attribution scholars to work for 10 years with various scenarios, then we might be well placed to make claims about, you know, there being evidence for the linguistic fingerprint or otherwise. But at this stage, I don't think it's possible. Thanks.
But so Christoph, so you think if you say that, then you assume that there is something out there. We just don't have enough research to get there, right? Yet.
I don't know, to be honest. You know, where I am at the moment, we with our various studies, you know, the picture that begins to emerge very clearly is that some people are really individual and easy to capture, even in a corpus of hundreds of thousands of authors, whereas some people just conform to the genre and to the expectations of the situation, the speech community, whatever, and they are just not there. They are completely transparent. Yeah. So I don't know. You know, we just need much more research. Thanks.
Okay, thank you very much, Christoph. James, do I see some sort of, like, do you want to add anything?
Well, so just maybe something, I think it was when my ears was suggested that people could sound more like each other, and I just wonder whether actually there's a slight difference here between what you're talking about and speech. I'd be interested to know what you think, actually, all of you, in the sense that when you speak, explain it this way, you've almost got two levels, right? You've got the physiological stuff, and then you've got what you might call the sociolinguistic stuff, or the thing that sits above it, or external factors that affect it. So things like, I don't know, the impact that, say, a heavy smoker would have on the vocal tract and what that would do to the voice and things like that. And it seems to me that that's kind of a difference here, because you know, if there are things that might change about my voice, but it's still my vocal tract, it's still my physical makeup of and you know, and there is still that kind of physiological link, which I guess we have, that perhaps, I don't know, in authorship you don't. Would that be a fair sort of thing to say? And that means that this genre stuff is more important. I don't know if that's me stepping out of my comfort zone, but I just wonder whether that is an actual difference between speech and writing, in the sense that there's a closer kind of link to the physiology of the vocal tract and the mouth and everything else, which aligns with the things that you know, the way that we talk and the style changes that go with different, you know, situations, that you perhaps don't have as one of that parallel, whether that parallel exists or doesn't exist in text or authorship analysis. That would just be what I was going to add.
Sorry, I think Christoph wants to.
Yeah, thanks. I'm sorry. I promise this is my last contribution.
It's fine.
I just wanted to refer to what James just said. I think the one advantage that you've got, James, is the existence of the vocal tract, and your question is actually one that we've been asking for textual data, and what we've got a new project. We've just collected 112 idiolects. 112 people performing in 7 different discourse types. Okay, if for a significant proportion of those people we can prove some kind of stability across all 7 discourse types, then I would then say yes, they each have got a textual vocal tract, if you like, right? At this stage, it's very unlikely when we look at the data. So, you know, the indication now is there's no vocal tract in writing, but we'll see. You know, we hope to begin publishing the results fairly soon. But I think that's a very good kind of you know, metaphor that we could use as well for textual data. You know, is there a vocal tract? Is it, you know, so are there stable linguistic patterns in writing? Thanks.
Interested to see what that throws out. And just perhaps the most uncontroversial thing I'll say today is, yes, I completely agree. Vocal tracks super useful for analysing speech.
I was wondering, Christoph, if you're still there, what kind of features you're looking at for this study? Because I imagine it also depends on the features, whether you find some sort of stability.
Yeah, absolutely. So what we, as a first approximation, we use as a point of access, we use n-grams, word n-grams, and part of speech n-grams. Okay, so that should give us enough information to begin with. But we're open to various types of experimentation. You know, we've used deltas, we've used neural networks. We've used KNN approaches as well that Maciej mentioned before. So yeah, but to begin with, you know, a very simple bag of words approach with word n-grams, and then that's going to be followed up by part of speech n-grams.
Can I actually add a couple of things, particularly going back to the reference to vocal tract? So people often said that, you know, speech is a bit different from, you know, text evidence, although they are, both of them, I call it linguistic evidence. Vocal tract, you know, because you know, each individual has a different vocal tract, that's the reflection of the different, you know, speech spectral features. And, you know, so that's why like a speech evidence is called semi-biometric, you know, evidence or something like that. Having said that, I can see the similarity between actually text evidence and handwriting evidence. Both of them I call behavioral evidence. There are a lot of different kinds of evidence, you know, chemical evidence, mechanical evidence, you know, biometrical evidence such as DNA, you know, so a lot of, you know, kind of evidence, part of different types of evidence. But, you know, I mean, we have to analyze all of those things because all of them are, you know, different, you know, types of evidence. So perhaps we just need to use a different kind of approaches for different types of evidence. So, you know. So I don't really think text evidence is so unique because I can see the similarity between the text and the handwriting. So you know, there are a lot of study on handwriting. So.
Right. Yeah, and yeah, there is we can say a class of evidence that's behavioral biometrics, right? So one is handwriting, then we have the way of body language in general. There are different, yeah.
That's right. And also another thing I wanted to add is right. So when you actually do analysis between the suspect and the offender, that's sort of a, you know, comparison of the two documents. In real forensic situation, you have to always deal with mismatch between them. Mismatch between, you know, like genre, topic, platform, you know, psychological state. There are a lot of factors which actually cause so-called mismatch between suspect offender, but also mismatch between those pieces of evidence against you know, background population data or something like that. So as Christoph said, one approach to that sort of mismatch, which is inevitable, is kind of find out robust features which can be applied to any sort of, you know, situations. That's the one way. But the other one is actually more kind of common people working on is building basically statistical models which compensate the mismatch evidence, which has been happening, you know, in a lot of different places, particularly those who used state-of-art, you know, deep learning, natural neural network type of models. And I can see similar sort of development in automatic forensic voice comparison systems. So people working on it.
Right. Are there any follow-ups? Otherwise, there's a question that's been asked by Anna Wegman. So if there, a clarification question about score-based versus feature-based measures. For the feature-based approach, are the features in the end not also compared by some similarity measure to decide on the authorship attribution question? Or in other words, feature-based measure is not also a form of score-based measure?
Actually, I have to say that the difference between feature-based and score-based methods is not well defined. Actually, some people might call the feature-based method I use is actually score-based method, but typicality and similarity-based score-based method. But the difference is whether you just use the single score, which is a univariate score, to kind of calculate like ratio, whereas feature-based method take advantage of the entire features with actually reducing the feature space into one single univariate space. That's the main difference.
Right. Yeah, that's a really good question. So maybe, do you think, Shunichi, do you think maybe a better terminology would be univariate versus multivariate?
I'm not sure. Different people call them differently. Perhaps Jeff Morrison might call it feature-based method, actually score-based method. But Aitken, for example, might call it feature-based method or something like that.
Okay, we are nearly towards the end, and I could continue this conversation for hours, but I would like to just ask you, members of the panels, if you want to say a few words as sort of any closing thoughts that you might want to add.
Well, maybe a tiny comment to this remark by Krzysztof that whatever is linked to literature is not transferable to forensic context, which is basically true, of course, but the forensic context itself is sort of vague because it can be also, proving that someone has plagiarized someone else's novel, right? So the question how to define the forensic context might be a bit blurry. But anyway, the thing is that I do believe that we do need more evidence, that we need more setups with short text, long text, high broad text, low broad text, aphasia-driven text, and so on and so on and so on and so on, right? So that we better understand what's there. Quite unfortunately, plenty of authorship attribution texts were using the same benchmark of the Federalist Papers, right? And we've lost like 2 or 3 decades of doing just but that one corpus, right? But I do believe that we'll be there in a couple of years' time, but we just need more evidence and more cross-checking of those methods and corpora. I think that the text variation, that's the biggest issue we are dealing with, rather than methodology. We roughly know which methods are better, which are outperforming other methods, but we cannot control for the corpus yet. That's a big unknown here. I mean, the texts themselves.
Okay, that's a very optimistic closing thought with a couple of years, but I agree with the general your general thought. Anything, Shunichi? Do you want to say anything?
Okay, or maybe I want to just advocate like ratio framework based kind of studies, because to me it is the logically and legally correct framework. Some people say it's a correct legally and logically correct framework. It doesn't really matter, but so it's just solid framework. And I think authorship analysis is basically engineering problem. We have to start from the kind of laboratory kind of conditions, and then moving on to more realistic, forensically realistic studies. I think that we are at the stage we should start working on more realistic kind of experiment, and then we start kind of working on the problem we encounter just one by one. That's something we just need to do. That is my understanding.
Great, thank you very much. James or Lynn? Don't have to.
Well, I just want to thank you again for the very kind invitation. As a historical linguist, this was way out of my comfort zone, but it was very nice to hear and get some new insights into forensic linguistics. So thanks for that.
Thank you for coming. It's very important for us to hear from you. That leaves us to James.
Well, I would just completely echo that, just to say that it's been, you know, a real pleasure and a privilege to be part of this, and I've learned loads today, you know, listening to people from different disciplines and talking about their work. And I think, you know, thanks to you, Andrea, and to David, and you know, the more of this kind of thing we can do, the better, as far as I'm concerned. So yeah, just thank you, and thanks to all the other panelists, and thanks for putting up with listening to me for a few hours as well. So yeah, much appreciated.
Okay, then that leaves the floor to me. I'll just say a few words to conclude. So this is the end of this very short and unusual. There are only 2 instances, but compared to the other one, unusual roundtable on practices and standards in forensic authorship analysis. And I hope you enjoyed the event. And if you have any feedback, please do send me an email. And we very, very much welcome ideas on other new things we can do next time, for example. And you know, we hope we can come back with a 3rd edition very soon, hopefully next year. And we also hope we will resume meeting in person as soon as possible. But our first roundtable was a hybrid event. So it was both in person and online, which nowadays sounds like it was a pioneering move ahead of its time. And it was actually suggested to us by the IFL Association, and we thought it was a great idea. And so I think this online component will stay even beyond the pandemic. And so I would like to thank the association, the IFL, again, for supporting us, and in particular, Tammy Gagels. I don't know if she's here now, because she was keeping up with us while we were trying to reschedule and find a way to make this work. And of course, a big thank you to the speakers who donated their precious time during these days to our initiative. So thank you, all of you who were watching from all parts of the world. The reason why we wanted to organize this is precisely to engage as many people as possible who have expertise and interest in authorship analysis. So your participation is an essential ingredient of this series of events. At this point, I would say let's move to the pub, but of course that's not going to happen this year. But if we manage to make more people aware of different perspectives and start conversations and collaborations, then hopefully we achieved our goal. So thank you everyone again, and we will see you at the 3rd roundtable, hopefully next year.